Hello, hello, hello. Let's see. Boop. Dun, dun, dun. I'm returned. Pin. Bruh. Okay. And no. Oh. Oh well. Hello, Monday. 1:22 on a Monday. Ugh. Blech. Does it look better or worse with the window? Um, is it that? Oh, I guess I could turn the light on and see how it looks. I don't exactly have it on. It's rather good backlighting. I think that's what that means. Lighting from behind. There we go. That is a better term. And then we have a light over there, which is the best I can get, especially when it gets darker. But now let's see. Is that good? That looks good. Yeah, that looks great. Shit. Before we actually start, oh, oh. I completely forgot about a thing. You. Give me this. Aha! We get some music to listen to. Oh, we can shuffle through it. Turn down the volume a bit. Anton Blast, huh? Well, okay. Now you guys can listen to this. I'm gonna go and use the bathroom real fast, and then we can start the stream properly. Alright. Now we may start. We last left off on hair troubleshooting. Yay! Ugh. I would have streamed yesterday if it weren't for the fact that okay, so we have a sister channel, right? Called Hergesbergen Company. And on Fridays and Saturdays, we stream Ace Attorney. However, we didn't get to do Ace Attorney on Saturday because of schedule conflicts. Yay. So, we ended up moving it to Sunday, and so I didn't get to stream on Sunday. Which is unfortunate, but oh well. At least I got some time to myself. So that was nice. Yeah. I think we can start. So, troubleshooting. This page lists common issues encountered when using Godot and possible solutions. See using the web editor for caveats, specific to the web version of Godot editor. The editor runs slowly and uses all my CPU and GPU resources, making my computer noisy. This is a known issue, especially on Mac OS, since the Macs have Retina displays. Due to Retina displays' higher pixel density, everything has to be rendered at a high resolution. This increases the load on the GPU and decreases perceived performance. There are several ways to improve performance and battery life. In 3D, click the perspective up button in the top left corner and enable half resolution. The 3D viewport will now be rendered at half resolution, which can be up to 4 times faster. Open the editor settings and increase the value of low processor mode to 33,000, 30 frames per second. This value determines the amount of microseconds between frames to render. Higher values will make the editor feel less reactive, but will help decrease CPU and GPU usage significantly. If you have a node that causes the editor to redraw continuously, such as particles, hide it and show it using a script in the ready method. This way, it will be hidden in the editor and will stay visible in the running project. The editor stutters and flickers on my variable refresh rate monitor. G-Sync FreeSync. This is a known issue. Variable refresh rate monitors need to adjust their gamma curves continuously to emit a consistent amount of light over time. This can cause flicker to appear in dark areas of the image when the refresh rate varies a lot, which occurs as the Godot editor only redraws when necessary. There are several workarounds for this. Enable interface editor, update continuously in the editor settings. Keep in mind this will increase power usage and heat noise emissions since the editor will now be rendering constantly, even if nothing has changed on screen. To alleviate this, you can increase low processor mode, sleep to 30 frames per second. In the editor settings, this value determines the amount of microseconds between frames to render. Higher values make the editor feel less reactive, but will help decrease CPU and GPU usage significantly. Alternatively, disable variable refresh rate on your monitor or in the graphics driver. VRR flicker can be reduced on some displays using the VRR control or fine-tune dark areas options in your monitor's OSD. These options may increase input lag or result in crushed blacks. What? Crushed blacks? I have no idea what that is. If using an OLED display, use the black OLED editor theme present in the editor settings. This hides VRR flicker thanks to OLED's perfect black levels. The editor or project takes a very long time to start. When using one of the rendering device-based renderers, Forward Plus or mobile, the first startup is expected to be relatively long. This is because shaders need to be compiled before they can be cached. Shaders also need to be cached again after updating Godot, after updating graphics drivers, or after switching graphics cards. If the issue persists after the startup, this is a known bug. On Windows, when you have specific USB peripherals connected, in particular, Corsair's ICUE software seems to cause this bug. Try updating your USB peripherals drivers to their latest version. If the bug persists, you need to disconnect the specific peripheral before opening the editor. You can then connect the peripheral again. Firewall software such as Portmaster may also cause the debug port to be blocked. This causes the project to take a long time to start, while being unable to use debugging features in the editor, such as viewing print output. You can work this around by changing the debug port used by the project and the editor settings network debug remote port. The default is 6007. Try another value that is greater than 1024, such as 7007.
Shelby.
No? Okay. On Windows, when loading the project for the first time after the PC is turned on, Windows Defender will cause the file system cache validation on project startup to take significantly longer. This is especially noticeable in projects with a large number of files. Consider adding the project folder to the list of exclusions by going to Virus and Threat Protection settings, add or remove exclusions. The Godot editor appears frozen after clicking the system console. When running Godot on Windows with the system console enabled, you can accidentally enable selection mode by clicking inside the command window. This Windows-specific behavior pauses the application to let you select text inside the system console. Godot cannot override the system-specific behavior. To solve this, select the system console, press window and system console window and press enter to leave selection mode. The Godot's editor macOS dock icon gets duplicated every time it is manually moved. I do not use macOS. Some text such as no DC appears in the top left corner of the project manager and editor window. This is caused by the NVIDIA graphics driver injecting an overlay to display information. To disable this overlay on Windows, restore your graphics driver settings to the default values in the NVIDIA control panel. To disable this overlay on Linux, open NVIDIA settings, go to I do not use a Linux driver. A microphone or refresh icon appears on the bottom right corner of the project manager and editor window. This is caused by NVIDIA graphics driver injecting overlays to display replay information on Shadowplay recording. This overlay can only be seen on Windows, as Linux does not have support for Shadowplay. To disable this overlay, press Alt-Z, default short for NVIDIA display. Do I have that? I do not have it. Great, so I don't need to worry about it. Editor project appears overly sharp or blurry. Correct appearance left. Sharpened appearance due to graphics driver sharpening right. If the editor or project appears overly sharp, this is due to the image sharpening being forced on all Vulkan or OpenGL applications by your graphics driver. You can disable this behavior in graphics driver's control panel. I think I'm fine. I don't really need to worry about it, because if it's a, I think I'm fine. Project appears to have washed out colors. Okay. I don't think I need to worry about the troubleshooting, because this appears to be editor specific problems, so if I come across any, I can just come back to it. Okay. I should take that. Allergy relief. My allergies have been awful today. I actually woke up at 8 today. Normally it's later, like 12. However, I went to bed early because I was feeling awfully tired. And my eyes have been super crusty today. Nose also pretty stuffy, and I've just been tired all day. I don't know why. Today might be a shorter stream. Because of that, I'm just so exhausted for no reason. And it's awful. Ugh. Really don't like it. Editor introduction. In this section, we cover the Godot editor in general, from its interface to using it with the command line. Editor's interface. The following pages explain how to use the various Windows workspaces and docs to make up the Godot editor. We cover some specific editors, interfaces in other sections where appropriate. For example, the animation editor. Using Project Manager, Inspector Doc, Project Settings, Script Editor, Default Editor Shortcuts, customizing the interface. XR Editor. Godot offers a port of the editor designed to run natively on MetaQuest devices. The port can be downloaded from the Meta Horizon store, or from the Godot download page, using XR Editor. Android editor, web editor, advanced features. The article below focuses on advanced features useful for experienced developers, such as calling Godot from the command line and using an external editor like Visual Studio Code or Emacs. Managing editor features. Godot allows you to remove features from the editor. This may be useful if you're an educator trying to ease students into the editor slowly, or if you're working on a project that's only 2D or 3D and don't want to see what you don't need. Actually, let's take a look at that. So, minimize that. Okay. Oh. I tried working on this project before, like I said before. This is what I got. None of this works. None of this functions, and I have stuff from a guy on the internet, but I think this looks really good. The movement of the background is very solid. Yeah, this, in general, this just looks good. Anyway. Let's see. Editor. Manage editor features. Create profile. That. Don't need the 3D editor, script editor, asset library, scene tree, note doc. Deprecated. Well, if it's deprecated, then I can just turn it off. Strip out game views, signals doc groups. Yep, just turn all of that off. Okay. Yay! Cool. Cool. Yeah, I have no idea how well this would actually work. Fight action magic item. I should probably change these up a bit. But anyway, let's take back and look at this next. Using the project manager. When you launch Godot, the first window you see is the project manager. It lets you create, remove, import, or play game projects. To change the editor's language, click on the settings button in the top right corner. Project manager settings, you can change the interface language from language drop-down menu, which in the system default language by default. You can also change the theme and color preset of the editor, the display scale for different interface element sizes, and the availability of online functionality using network mode. If network mode is online, Godot will also check and inform you about new versions of Godot. The directory naming convention can also be changed to replace spaces according to the chosen format when creating folders automatically. Creating importing projects. To create new project, blah blah blah. Note, you can optionally choose a version control system. Currently only Git is supported, and it needs the Godot Git plugin to be installed, either manually or using the asset library. To learn more about the Godot Git plugin, see its wiki. I think I have... Yeah. Using the file browser. From the Create New Project window, click the Browser button to open Godot's file browser. You can pick a location or type the folder's path in the path field. After choosing a drive, left of the path on the top row contains arrows to navigate backwards and forward through the last visited locations. The up arrow navigates to parent folder. On the right side of the path field, there are buttons to refresh the current folder's contents, favorite, unfavorited, the current folder, and show, hide, hidden folders. Next, the buttons to switch the display type of the folders and files between grid view and list view are seen. The last button on the right will create a new folder. Favorited folders will be displayed on the left side under the favorite section. You can sort the favorites using the up and down buttons in this section. Last chosen folders will be listed under the recent list. I cannot get that song. And I don't mean I don't like the song. I love the song. It's the fact that I love the song that I cannot. Because it's highly distracting. So distracting. Can I... Okay. That is not what I need to be looking at. This is what I need to be looking at. Opening importing projects. The next time you open the project manager, you'll see your new project in the list. Double-click on it to open it in the editor. You can similarly import existing projects using the import button. Locate the folder that contains the project or the file.godot file to import and edit it. Alternatively, it is possible to choose a zip file to be automatically extracted by Godot. When the folder path is correct, you'll see a green check mark.
Shelby! Shelby. Hello, pretty girl. You just gonna hang out there? Okay. You do you.
Alternatively, it is possible to choose a zip file automatically extracting by Go, and the path you'll see a green check mark. Downloading demos and templates. From the Asset Library tab, you can download open source project templates and demos from the Asset Library to help you get started faster. The first time you open this tab, you'll notice that it's asking you to go online. For privacy reasons, the project manager and Godot editor can't access the internet by default. To enable accessing the internet, click the Go Online button. This will also allow Project Manager to notify you about updates. If you wish to turn this off in the future, go into Project Manager settings and change network mode to offline. Now that Godot is connected to the internet, you can download a demo or a template. To do this, click on its title. On the page that's open, click the download button. Once it's finished downloading, click install and choose where you want to save the project. Managing projects with tags. For users with a lot of projects on one PC, it can be a lot to keep track of. To aid in this, Godot allows you to create project tags. To add a tag or to a project, click on the project in the Project Manager, then click on the Manage Tags button. This will open up the Manage Project Tags window. To add a tag, click the plus button. Type out the tag name and click OK. Your project will now have a tag added to it. These tags can be used for any other project in your project manager. To show projects with a specific tag only, you can click on the tags or write tag and type the tag you would like to search for in the filter bar. To limit the results using multiple tags, you can click on another tag or add tag after a space and type another tag in the filter bar. What did I say earlier? Okay, I'm going to fix this. No, private. Select that, select that, 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 There we go. In addition, tags will stay with projects. So if you tag your project, send it to another machine, and import it into the project manager, you will see the tags you created. To remove a tag from your project manager, it must be removed from all projects it's used by. Once that's done, close the project manager, open it up again, and the tag should be gone. Recovery mode. If a project is immediately crashing on startup or crashing frequently during editing it, it can be opened in recovery mode to attempt to make it more stable while looking for the source of the crashing to fix it. Usually, a project should open in recovery mode automatically when you reopen it after a crash. If it doesn't, you can manually open recovery mode by selecting the project in the project manager. To do that, select the project from your list of projects, click the drop-down button next to the edit node, and select edit in recovery mode. While in recovery mode, the following are disabled: tool scripts, editor plugins, GD extension add-ons, automatic scene restoring, running the project. It is recommended that you back up your project before editing it in recovery mode. Inspector Doc. The Inspector Doc lists all properties of an object, resource, or node. It will update the list of properties as you select a different node from the scene tree doc, or if you use open command from the file system's context menu. This page explains how the Inspector Doc works in depth. You will learn how to edit properties, fold and unfold areas, and use the search bar and more. Usage. If the Inspector Doc is visible, clicking on a node in the scene tree will automatically display its properties. If it is not visible, you can show it by navigating to Editor, Editor Docs, Inspector. At the top of the dock are the File and Navigation buttons, from left to right. Opens a new window to select and create a resource in the memory and edit it. Opens a resource from the file system to edit. Saves the currently edited resource to disk. Control S. Just automatically save shit. Provides options to edit resources from clipboard by pasting the copied resource. Copy resource to clipboard, show in file system if the resource is already saved. Make resource built in to work in a built-in resource, not the one from the disk. The arrows let you navigate through your edited object history. The button next to them opens the history list for a quicker navigation. If you created multiple resources in the memory, you will also see them here. Below, you can find the selected node's icon, its name, and the quick button. It opens its documentation on the right side. Clicking on the node's name itself will list the sub-resources of the node if there are any. Then comes the search bar. Type anything in it to filter displayed properties. Delete the text to clear the search. This search is case sensitive and also searches letter by letter as you type. For instance, if you use VSB, one of the results you see will be visibility property, as this property contains all of these letters. Before discussing the tool button next to the filter bar, it's worth mentioning that what you actually see below it and how it's structured. Class. Properties, sections. Properties are grouped inside their respective classes as sections. You can expand each section to view the related properties. You can also open the documentation of each class by right-clicking on a class and selecting Open Documentation. Similarly, you can right-click on a property and copy or paste its value, copy the property path, favorite it to be shown on the top of the inspector, or open its documentation page. If you hover your mouse over a property, you will see the description of what it does as well as how it can be called inside the script. You can directly change the values by clicking, typing, or selecting from the menu. If the property is a number or a slider, you can keep your left mouse button pressed and drag to change the values. If a node's property is a sub-resource, you can click on the down arrow to pick a resource type or load one using the quick load or load options. Alternatively, a supported resource can be dragged from the file system. Once you start dragging, the compatible property will be highlighted. Simply drop it on the appropriate properties value. After loading a sub-resource, you can click on it to see its properties or adjust them. The values with different values than their original values will have a revert icon. Clicking on this icon reverts a value to its original state. If the values are linked with each other, they will have a chain icon. In changing, one will change others as well. You can unchain them by clicking on this icon. If you are changing a property a lot, you may consider favoriting it by right-clicking and choosing Favorite Property. This will show you at the top of the inspector for all objects of this class. Now that we have a better understanding of the terms, we can proceed with the tool menu. If you click the tool menu icon next to the filter bar, a drop-down menu will offer various view and edit options. Expand all expands all sections showing all available properties. Collapse all collapses all properties showing only classes and their sections. Expand non-default only expands the sections where the original value is different than the current value. The properties with a revert icon. Property name style. This section determines how the property's text is displayed in the inspector. Raw uses property zone naming. Capitalize uses title case by changing the initial letters of each word to uppercase and removing underscores. Localize displays the translation of the properties if you are using the editor in a language other than English. Copy properties copies all properties of the current node with their current values. Paste properties paste the copied properties from the clipboard. Useful to apply the common properties of one node to another. Make sub-resources unique. By default, a duplicated node shares the sub-resources of the original node. Changing the parameter of the sub-resource in one node affects the other one. Clicking this option makes each sub-resource used in this node unique, separated from other nodes. If a node has exported variables in its attached script, you will also see these in the inspector. The first image in this section has one for the player node, action suffix, CGD script exported properties for more on this topic. See also refer to customizing the interface for dock customization options. I got tea. And no dog. I want Doggo though. But I guess they don't want me. Right now. Oh well, they can do their own thing. I won't force them to do anything. Got some Lipton iced tea peach. Pretty good. Not sponsored though, of course. Why would somebody with only 2 subscribers and like a total of 10 views be sponsored by anyone? That's just ridiculous. Still good though. Project settings. There are dozens of settings you can change to control a project's execution, including physics, rendering, and window settings. These settings can be changed from the project settings window, from code, or by manually editing the project Godot file. You can see a full list of settings in the project settings class. Internally, Godot stores these settings for a project in the project.godot file, a plain text file in the ini format. While this is a human-readable and version control-friendly, it's not the most convenient to edit. For that reason, the Project Settings window is available to edit these settings. To open the Project Settings, select Project Settings from the main menu. Project Settings window. The Project Settings window is mainly used to change settings in the General tab. Additionally, there are tabs for input map localization, globals, plugins, and import defaults. Usage of these other tabs is documented elsewhere. Changing project settings. The General tab of the Project Settings window works much like the inspector. It displays a list of project settings which you can change, just like inspector properties. There is a list of categories on the left, which you can use to select related groups of settings. You can also search for a specific setting with the Filter Settings field. Each setting has a default value. Settings can reset to their default values by clicking the circular arrow reset button next to each property. Changing project settings from code. You can use set setting to change a settings value from code. However, many project settings are only read once the game starts. After that, changing the setting with set setting will have no effect. Instead, most settings have a corresponding property or method on a runtime class like engine or display server. In general, project settings are duplicated at runtime in the engine. Physics Server 2D, Physics Server 3D, Rendering Server Viewport, or Window classes in the project settings. Class reference settings links to their equivalent runtime property or method. Reading project settings. You can read project settings with the get setting or get setting with override. Since many project settings are only read once at startup, the value in the project settings may no longer be accurate. In these cases, it's better to read the value from the unique runtime equivalent property or method. Manually editing project.godot. You can open the project.godot file using a text editor and manually changing the project settings. Note that if the project.godot file does not have a stored value for a particular setting, it is implicitly the default value of that setting. This means that if you are manually editing the file, you may have to write in both the setting name and the value. In general, it is recommended to use the project settings window rather than manually edit project.godot. Advanced project settings. By default, some of the project settings are shown. To see all the project settings, enable the advanced settings toggle. Interesting. No, it's just lighting making it look weird. How much we got in this section? A bit. Script editor introduction. Godot's Engine script editor is a powerful and fully integrated text editor that not only streamlines the process of writing and debugging code written in GDScript, but also allows for working with plain text files, providing developers with a seamless environment for scripting game logic and behaviors. It can highlight your code, automatically indent it, perform syntax checks, and much more. You can also create breakpoints to debug your project without switching to another window. The text editor also serves as an offline class reference viewer, which can be accessed in several ways as described in the integrated class reference. Features. Some of the key features of the text editor are listed below. Fully integrated code editor for GDScript. Syntax highlighting, support for GDScript and JSON files. Syntax checking for GDScript and JSON files. Bookmark and breakpoint support, automatic indentation, code folding, customizable theme, multiple carets, which can be enabled using Alt-left click, auto-completion of variables, functions, constants, etc., inline refactoring of symbols by selecting them and using Ctrl-D, mass find, and replace across project files. Usage. If you are using GDScript in your project, the built-in editor in Godot provides everything you need. Serves as a one-stop location to fully utilize the Godot engine. Nearly all parameters that can be adjusted via the user interface can also be modified directly through code. If you would like to use external text editor or prefer to use C# in your project, see using an external text editor and configuring an external editor. Tips. Similar to many parts of the Godot's interface, the text editor can also be customized by changing its settings to your liking. You can access these settings by opening Editor Settings, and going to the Text Editor group. You can open the Script Editor using the Script button in the Workspace selector, located at the top center of Godot's interface. Alternatively, you can use the Open Script button next to a node in the Scene Tree dock, or double-click on a .gd file or a recognized text file in the file system dock to open it directly in the Script Editor. Once it is open, you will see the text editor menus at the top. Below the scene switcher, next to the menus, you'll find buttons to open the online documentation or search within the built-in class reference. To the right of these buttons are two navigation arrows that allow you to navigate through your viewing history. Finally, you can use the float button to separate the text editor from the Godot's window, which is useful if you are working with multiple monitors. Which I am. Yay! However, However, I only have 2 monitors, and one of them has Streamlabs on it, so that I can manage the streaming. So yeah, but it's been 40 minutes already. Damn. Where was I? Underneath the menus on the left, you'll see the script panel. In the center, adjacent to the script panel, is the coding area. Beneath the coding area is the status bar, which displays the error and warning count in the code. Clicking on the error or warning icons will show the list of errors with the line numbers. Clicking on one will jump to that line. You can also choose to ignore warnings by opening the list and clicking ignore. The status bar also lets you change the zoom level of the code by clicking the percentage value. You can also use Control mouse wheel, Command mouse wheel on Mac to achieve the same effect. The status bar also shows the current position of the caret in terms of line and column, and whether the indentation is done using tabs or spaces. Many of the actions performed in the text editor can also be executed using shortcuts. The actions shown show their corresponding shortcuts next to them. For complete shortcut lists, see the text editor shortcuts. In the next section, we will go through different aspects of the text editor. You can also select a section below to jump to a specific topic. Script panel, menus, coding area. Script panel. Below the menus, on the left panel, you will see a list of open files and documentation pages. Depending on the file type, this list will have an icon next to the file name. For example, the gear icon means that it is a GD script. The gear CS means that it is a C# script. The doc means that it is a built-in class reference. Finally, the blue cog means it's currently running script. See the tool annotations for more on this. Hovering a file will show a tooltip with its relative location in the project folder. On the status bar, clicking the left arrow hides the script panel. Clicking on the right arrow shows it. If you did not change any settings, the file names may also have a different coloring. This helps you identify the recently edited files by highlighting them. This behavior can be changed in the editor settings by adjusting the script temperature properties in the text editor section. The filter bar above the file names introduces a handy case insensitive search to find a specific file. Even if you just type the letters of a file name into the bar, files containing these letters in order will also appear, assuming that there is a file named button.gd in the list. If you type button into the filter bar, this file will appear in the results. To reset the filter, clear the filter bar. An asterisk next to a file name indicates that the file has unsaved changes. If you just enter asterisk into the filter bar, you can display all unsaved files. That's useful. You can drag a file to change the ordering. Middle-click on a file closes it. Right-click on a file provides several options to save or close files, or to copy the relative path of the file. On this menu, you can also use move up and move down to change the order of the file, or use sort to sort all files alphabetically. Toggle scripts panel hides the panel which can be displayed using the arrow on the status bar. Close docs closes all opened in class reference documents, leaving only script files open. Show in file system finds and highlights the file in the file system doc. Below the file list, you'll see the name of the currently open file. The button next to this switches the ordering of the methods defined in this file between alphabetical and as they appear. Under this is the outline of the file. If this is a script file, it will contain the list of defined methods. If, however, a class reference page is open, the area will show the table of contents of this document. Clicking on an item in this list will jump to the respective function or section in the file. Similarly, the filter methods bar lets you search for a specific function or section within the selected documentation with the same behavior as filtering scripts.
Shelby. Doggo. Doggo. Shelby.
No. Alright. Menus. The text editor menus lie below the scene switcher and allow you to access a variety of tools and options such as file management, search and replace, debugging controls, and code formatting features. Tip: an asterisk next to an action means that this operation is also available in the context menu, which can be opened by right-clicking in the code editor. The file menu provides the following options. Oh shit, forgot about something. I forgot to get into here. Silly me. Now they don't know I exist. And by they, I mean my little helpers. The file menu provides the following options. New script opens the new script dialog to create and add the script to the project. If creation is successful, it will directly open in the text editor. Depending on the version of Godot, with C# support or not, you can choose GD or .gd or .cs as the extension. New text file opens the file dialog to create a plain text file with one of the recognized formats. Godot can also highlight JSON files. Open opens the file dialog to let you browse inside your computer and choose any recognized text file to open it. Reopen close script reopens the last closed script. You can use this option multiple times to reopen other closed scripts if you close more than one. Open recent provides a list of last opened scripts. You can also clear the list using the provided option at the bottom of the list. Save saves the current selected script. Save as opens the file dialog to save the currently open script with a different name. Save all saves all unsaved open scripts in the text editor. Scripts with unsaved changes will have an asterisk next to their names in the scripts list. Soft reload tool script. If the selected script is a tool, reloads the script to execute it again. Copy script path copies the currently selected script's relative path in the project using the res prefix. Show in file system finds and highlights the selected file in the file system doc. History previous changes the active script to the one that was previously opened. This is useful when you have multiple scripts open and want to quickly navigate back to the last script you were editing. If you also changed the caret position more than 10 lines, you will first move it to the previous location in the same file. History next after using history previous to go back to an earlier script. This feature allows you to move forward through the script history, switching to scripts that were previously accessed. Similar to above, if you also change the caret position more than 10 lines, you will first move it to its next location in the same file. Theme provides options to import an existing theme, save or reload it. Changing theme settings is performed via editor settings. Close closes the active script. Close all closes all open scripts and prompts to save if there are unsaved changes. Close other tabs closes all open scripts except the selected one. Close docs close the class reference documentation pages, leaving only the scripts. Run if the script extends editor script and intended to be executed without running the project. This option runs a script. See running one-off scripts using editor script for more. Toggle script panel shows or hides the script panel located on the left side of the text editor, allowing you to expand the available coding area. More on the scripts panel is explained above. The edit menu provides several options for the line operations. Undo allows you to reverse the most recent action or series of actions, restoring documentation or code to its previous state before the changes were made. Redo allows you to reapply any action that was previously undone, effectively redoing the last action that was reversed by the undo function. Cuts the selection of the clipboard. Paste the content of the clipboard if it contains text. Select all selects the all code in the text editor. Selects the all code in the text editor. Don't you mean all the code? Not the all code? Eh. Duplicate selection. Copies the selection and appends it to the next selection. Duplicate lines. Duplicates the current line and adds it to the new line below the current line. Evaluate selection. Computes the value of the selected text if it contains only mathematical expressions such as a 3 times 3 or power 2 to the power of 3. Toggle word wrap. Disables the horizontal scroll bar by wrapping the long lines to the next line. Note that this is just a visual change and no new line breaks are added. Line provides a set of line operations depending on the opened file. The options might also be directly in the edit menu instead of a submenu. Move up moves the current line or the selected lines one line up. Move down moves the current line or selected lines one line down. Indent indents the text from the caret or the selected lines following the indentation setting. Unindents the text from the caret or selected lines following the indentation setting. Delete line deletes the current line or the selected lines. Toggle comments, and uncomments the current line or the selected lines. You can perform the same action by selecting lines and choosing the same action after right-clicking on the selected text. Folding provides a set of folding options for the selected text, depending on the opened file. The option might also be directly in the edit menu instead of a submenu. Fold unfold line. If a code in the current line has a code block or a code region beneath it, it hides this block from collapsing the lines. You can then unfold it using this option again, using the arrow next to the line number in the coding area or clicking the ellipses icon at the end of the folding line. Fold all lines. Folds all code blocks or code regions in the open document. Unfold all lines. Unfolds all code blocks and code regions in the open document. Create code region. Wraps the selected code text in a foldable code region to improve the readability of larger scripts. See built-in types for more. Completion query suggests from built-in or user-created symbols to autocomplete the partially written code. Up and down arrows navigate up and down, pressing Enter or Tab accepts and adds the highlighted symbol to the code. Tab will also replace existing text to the right of the caret. Trim trailing white spaces. Removes extra spacing at the end of each line in the file. Trim file new lines. Removes the extra new lines at the end of the file. Indentation provides options for the indentation of the open file. Depending on the opened file, the options might also be directly in the edit menu instead of a submenu. Convert indent to spaces. Converts all indentation in the file to spaces. Convert indent to tabs. Converts all indentation in the file to tabs. Auto indent converts the indentation of the selected lines or the entire file following the indentation setting. Convert case changes the case of the selected text to uppercase, lowercase, or capitalizes each initial letter of the word. Syntax highlighter allows you to choose the syntax highlighter. Plain text disables highlighting, standard default highlighting for C# scripts, JSON syntax highlighted for JSON files, GDScript syntax highlighting for GDScript files. The search menu provides the following options. Find opens the quick find bar under the status bar to search for text in the open file. You can navigate to the next match and previous match using the up and down arrows respectively. Checking match case makes the search case sensitive. Checking whole words means that the text must not have any letters or numbers next to it, only symbols and white space. Find next similar to the down arrow shows the next occurrence. Find previous similar to the up arrow shows the previous occurrence. Replace opens the find and replace bar under the status bar to find text and replace it in the open file. You can choose to replace them one at a time or all at once. Additionally, you can limit the replacement to the selected text by checking the selection only checkbox in the find and replace bar. You can also use Ctrl-D to additionally select the next instance of the currently selected text, allowing you to perform an inline replacement on multiple occurrences. Find in files opens a window to search for text within the files in the project folder. Selecting Find starts with the chosen folder and includes the file extensions checked in the filters. The results are shown in the button panel with the number of matches and total numbers of files found. In the Search Results tab, clicking on Result opens the file and jumps to the respective line. Replace in Files opens a window to search and replace text with different text within the found files in the project folder. After clicking Replace, you can select in which files to replace using the Search Results tab in the bottom panel by unchecking them and using Replace All button. Hello, welcome to the stream.
Hi.
We're nearly an hour in. What are you doing?
Something I probably should have done a while ago.
Which is?
Starting the 4th games compilation at the same time so that they both get finished at the same time. Because I managed to work that out.
Really?
Yep. All I have to do is tank the first 3 Apollo Justice recordings today and do the 3rd recording of Trials and Tribulations, and then I'm on track by doing one of them each every day. It'll be finished
Lovely.
the same day we start 5-4.
Huzzah!
Fuck.
Yeah, major fuck.
And then if I keep doing that with Game 5's cases, we'll be completely caught up before we even start 5-5.
Oh, nice. You're... Don't stop him now. Don't stop him now. 'Cause he's having a bad time. Having a bad time.
You know, looking at the audio thing for this first Apollo Justice episode, it is like comically loud.
Yeah.
Do you want to see what I'm looking at here?
Sure, why not? Let's take a look. See here. Oh, why is it peaking so much?
I have absolutely no idea. It could just be because of how much I'm zoomed out, but it looks comically loud.
It does. Why?
I don't know. Let's see how
What?
loud it actually is. It's actually not that bad.
Well, we haven't even gotten to the peaking parts yet.
Oh, yeah, that's it. Okay. Yeah, that. Oh, right. Fuck you, voice.
Okay. Alright.
And then I sit here for like 5 minutes trying to figure out what to do.
Silly.
Fuck.
What are we listening to? No, not this. Little cat feet. Is this one shot? Oh yeah, it is one shot. Cool. Warning! Note that replace in files operation cannot be undone. Both the find in files and replace in files windows share the search and replace buttons. The only difference in the latter window is an additional text field that automatically fills in the search results panel when the replace button is clicked. The replacement operation is only executed if you click the replace all button in this bottom panel, following you to also edit the word to replace later within this panel. Contextual help opens the list of built-in class reference similar to pressing F1 on a symbol or choosing lookup symbol from the context menu. The go to menu lets you navigate within the code at ease with these options. Go to function opens the function list to jump to. You can achieve the same result by typing in the filter methods bar in the script panel. Go to line jumps to the entered line number in the code editor. Bookmarks contains the contains actions for the bookmark functionality, which you can use to find your way through your code easier, such as an incomplete section. Bookmark lines will have a blue bookmark symbol left of the number line. Toggle bookmark adds or removes bookmark on the line where the care is. You can also right-click on a line to achieve this. Remove all bookmarks removes all bookmarks in the open document. Go to next bookmark, jumps to the next bookmark in the open document. Go to previous bookmark, jumps to previous bookmark in the open document. Bookmarks menu will also contain the list of bookmarked lines, including their line number, and displayed the partial content in that line. Breakpoints. Breakpoints are helpful while debugging your code, similar to Bookmarks menu. This menu lets you add or remove breakpoints, navigate between them, and directly jump to a specific breakpoint. An easy way to add a breakpoint is hovering over the blank area left of a line number. It will show a faded red circle. Clicking it will add a breakpoint, and the circle will stay there. Clicking on a circle removes the breakpoint. Debug menu offers actions which can be used while debugging. See script editor debug tools and options for more. Coding area. Note this section will only cover the basics of the coding area in terms of the user interface. To learn more about scripting in Godot, refer to the GD script or scripting documentation. The coding area is where you will type your scripts if you are using the built-in text editor. It offers highlighting the auto-completion features to help you while you code. The coding area shows line numbers on the left side. Below the navigation arrows on the right side, there is a clickable minimap that provides an overview of the entire script, allowing you to scroll through it. If a line of code is long enough, more than 80 characters by default, the text editor will display a vertical line that can be used as a soft guideline. For a hard guideline, this value is set to 100 characters by default. Both values can be changed, or the display of the line can be toggled in the appearance settings of the text editor. In the script to the left of the function definitions, you might see additional icons. The arrow icon indicates that this function is an override of an existing function. Clicking it opens the documentation of the original function. The green arrow icon means that it is a receiving method of a signal. Clicking it shows where the signal is coming from. A arrow icon to the left of the line denotes a foldable block. You can click or collapse or expand it. Alternatively, the ellipses icon can also be clicked to expand a folded block. The example below summarizes the paragraphs above. Lines 52, 56, and 58 are foldable blocks. Line 57 is a code region with the name new code region, which you can also fold. And line 62 is a folded block. Line 53 is a bookmark, which can quickly jump to using the Go To Bookmarks menu. Line 55 is a breakpoint that can be used in debugging. Many of the colors in the text editor, such as highlighted colors or even breakpoint or bookmark icon colors, can be customized. You can experiment them by opening the text editor settings, navigating to editor settings, text editor section. Hey, new section. I think. Or is this still editor introduction? Holy, this is a lot. Work in progress. The content of this page was not yet updated for Godot 4.6 and may be outdated. If you know how to improve this page or you can confirm that it's up to date, feel free to open a pull request. Default editor shortcuts. Many Godot editor functions can be executed with keyboard shortcuts. This page lists functions which have associated shortcuts by default, but many others are available for customization in editor settings and as well. To change keys associated with these and other actions, navigate to editor settings, shortcuts. While some actions are universal, a lot of shortcuts are specific to individual tools. For this reason, it is possible for some key combinations to be assigned to more than one function. The correct action will be performed depending on the context. Note, while Windows and Linux builds of the editor share most of the default settings, some shortcuts may differ for macOS version. This is done for better integration of the editor into macOS ecosystem. Users fluent with standard shortcuts on the OS should find Godot Editor's default key mapping intuitive. That's a lot. Action name, open 2D workspace, control F1, open 3D workspace, control F2. I don't need to worry about it. Bottom panels. Only bottom panels that are always available have a default shortcut assigned. Others must be manually bound in the editor settings if desired. 2D canvas item editor, 3D spatial editor, text editor, script editor, editor output, debugger, file dialog, file system doc, scene tree doc, animation track editor, tile map editor, tile set editor, grid map editor, project manager. Damn. Customizing the interface. Godot's interface lives in a single window by default. Since Godot 4.0, you can split several elements to separate windows to better make use of multi-monitor setups. Moving and resizing docks. Click and drag on the edge of any dock or panel to resize it horizontally or vertically. Resizing a dock in the editor. Click the 3 vertical dots icon at the top of any dock to change its location, or split it to a separate window by choosing Make Floating in the submenu that appears. Moving a dock in the editor. To move a floating dock back to the editor window, close the dock window using the X button in the top right corner of the window, or in the top left corner on macOS. Alternatively, you can press Alt F4 while the split window is focused, splitting the script or shader editor into its own window. Note, this feature is only available on platforms that support spawning multiple Windows, macOS, and Linux. This feature is also not available if single window mode is enabled in the editor settings. Since Godot 4.1, you can split the script or shader editor to its own window. To split the script editor to its own window, click the corresponding button in the top right corner of the script editor. To split this shader editor to its own window, click the corresponding button in the top right corner of the script editor, splitting the shader editor to its own window. To go back to the previous state with the script shader editor embedded in the editor window, close the split window using the X button in the top corner of the window, or in the top left corner of the Mac OS. Alternatively, you can press Alt F4 while the split window is focused. Customizing editor layouts. You may want to save and load a dock configuration depending on the kind of task you're working on. For instance, when working on animating a character, it may be more convenient to have docks laid out in a different fashion compared to when you're designing a level. For this purpose, Godot provides a way to save and restore editor layouts. Before saving a layout, make changes to the docks you'd like to save. The following changes are persisted to the saved layout. Moving a dock, resizing a dock, making a dock floating, changing a floating dock's position or size, file system dock properties, split mode, display mode, sorting order, file list, display mode, selected paths, and unfolding paths. Note, splitting the script or script shader editor to its own window is not persisted as part of a layout. After making changes, open the editor menu at the top of the editor, then choosing editor layouts save. Enter a name for the layout, then click save. If you've already saved an editor layout, you can choose to override an existing layout using the list. After making changes, open the editor menu at the top of the editor, then choose editor layouts. In the drop-down list, you'll see a list of saved editor layouts, plus default, which is a hard-coded editor layout that can't be removed. The default layout matches a fresh Godot installation with no changes made to the dock's positions and sizes, and no floating docks. You can remove a layout using the delete option in the editor layouts drop-down. Tip: if you name the saved layout default case sensitive, the default editor layout will be overwritten. Note that the default editor does not appear in the list of layouts to overwrite until you overwrite it once, but can still write its name manually. You can go back to the standard default layout by removing the default layout after overwriting it. This option does not appear if you haven't overridden the default layout yet. Editor layouts are
Dude,
saved.
I'm getting mad at myself here. It's not that hard to figure out a voice for Apollo, is it?
Oh, it most definitely is.
Jesus.
You just keep switching to different ones.
Well, uh, it's the same general idea.
Just deeper.
It just keeps getting randomly deeper.
Yeah. We
Like
pointed that
that one
out
time I
several
perfectly
times.
sounded like Manfred von Karma and will never achieve it
Arrgh!
again.
That was more
That's just
Judge. That's
judge.
just Judge.
You can't do gravelly old men.
What do you mean?
All you can do is the judge.
That is a gravelly old man. I'm the judge.
Yet you can do gravelly old man, but not men.
Yeah. Can you do gravelly old men?
No.
Exactly.
I
That's what
never
I
said I
thought.
could. I was just pointing out the obvious.
And my point is, it's hard to do gravelly old men.
It is.
For anyone, really.
Yo. Oh, yeah.
What's up?
Fucking hell, where do I keep putting my wallet? Bathroom, maybe? Probably, I'm dumb.
Customizing editor settings. In the editor menu at the top of the editor, you can find an editor settings option. This opens a window similar to the project settings, but the settings used by the editor, these settings are shared across all projects and are not saved in the project files. Some commonly changed settings are interface editor language. Controls the language the editor displays in to make English tutorials easier to follow. You may want to change this to English so that the menu names are identical to names referred to by tutorials. The language can also be changed in the top right corner of the project manager. Interface editor display scale controls how large UI elements display on screen. The default auto setting finds a suitable value based on your display's DPI and resolution due to the engine's limitations. It only takes the display provided scaling factor on Mac OS, not on Windows or Linux. Interface editor single window mode. If enabled, this forces the editor to use a single window. This disables certain features such as splitting the script shaders editor to their own window. Single window mode can be more stable, especially on Linux when using Wayland. Interface theme preset. The editor theme preset to use. The light theme preset may be easier to read if you're outdoors or in a room with sunlight. The black OLED preset can reduce power consumption on OLED displays, which are increasingly common in laptops and phones/tablets. File system, directories, autoscan, project path. This can be set to a folder path that will be automatically scanned for projects in the project manager every time it starts. File system, directories, default project path. Controls the default location where new projects are created in the project manager. Editors 3D emulate numpad. This allows using the top row 0 to 9 keys in the 3D editor as their equivalent numpad keys. It's recommended to enable this option if you don't have a number pad on your keyboard. Editors 3D emulate 3-button mouse. This allows using the pan, zoom, and orbit modifiers in the 3D editor even when not holding down any mouse button. It's recommended to enable this option if you're using a trackpad. See the editor settings class reference for a complete description of most editor settings. You can also hover an editor settings name with the mouse in the editor settings to show its description. Okay, we're on to a new section now. I need to use the bathroom. Again, I know. I only used it an hour ago. Alright, I'm back. Using the XR editor. Da, 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 da. XR, VR. Or AR systems, I would assume. VR AR systems. Using the Android editor. I'm not going to be using the Android editor. Web editor. Not going to use the web editor. Command line tutorial. Probably not going to be using the command line. But if I do, I'll just come back to this. Use an external text editor. No. Using the engine compilation configuration editor. What? Godot comes with a large set of built-in features. While this is convenient, this also means its binary size is larger than it could be, especially for projects that only use a small portion of its feature set. To help reduce binary size, it is possible to compile custom export templates with certain features disabled. This is described in detail in optimizing a build for size. However, determining which features need to be disabled can be a tedious task. The engine compilation configuration editor aims to address this by providing an interface to view and manage these features easily, while also being able to detect the features currently being used in the project. The Project Tools Engine Compilation Configuration Editor allows you to create and manage build profiles for your Godot project. From now on, you have two possibilities. View the list and manually uncheck features that you don't need. Use the Detect from Project button to automatically detect features currently used in the project and disable unused features. Note that this will override the existing list of features, so if you have manually unchecked some items, their state will be reset based on whether the project actually uses the feature. Opening the Engine Compilation Configuration Editor. Once you click Detect from Project, the project detection step will run. This can take from a few seconds up to several minutes depending on the project size. Once detection is complete, you will see an updated list of features with some features disabled. Updating features list after using feature detection. Example from the 3D platformer demo. Warning, unchecking features in this dialog will not reduce binary size directly on export, since it is only possible to actually remove features from the binary at compile time. You still need to compile custom export templates with the build profile specified to actually benefit from the engine compilation configuration editor. You can now save the build profile by clicking Save As at the top. The build profile can be saved in any location, but it's a good idea to save it somewhere in your project folder and add it to version control to be able to go back to it later when needed. This also allows using version control to track changes to the build profile. The build profile is a JSON file and .gd build extension that looks like this after detection in the above example. This file can be passed as a scons option while compiling export templates. The build system will use this to disable unused classes and reduce binary size as a result. Limitations. The detect from project functionality relies on reading the project scenes and scripts. It will not be able to detect used features in the following scenarios. Features that are used in GD scripts that are procedurally created then run at runtime. Features that are used in expressions. Features that are used in GD. Scripts are procedurally created, then run at runtime. Features that are used in expressions. Features that are used in GD extension, unless the language binding allows for defined used classes, and the extension makes use of the functionality. See GH104129 for details. Features that are used in external PCKs loading at runtime. Certain edge cases may exist. If unsure, please open an issue on GitHub with a minimal production project attached. See also, you can achieve further size reductions by passing other options that reduce binary size. See optimizing a build for size for more information. Work in progress. Okay. Managing editor features in production. In certain situations, it may be desirable to limit what features can be used in the Godot editor. For example, a UI editor on a team who doesn't need to see 3D features, or an editor slowly introducing features to students. Godot has a built-in system called Feature Profiles. To do this, with feature profiles, major features and nodes can be hidden from the editor. This only hides parts of the interface and does not actually remove support from these features. So scenes and scripts relying on those features will still work fine. This also means feature profiles are not an optimization technique for information on how to optimize Godot. See performance. Creating a profile. To manage editor creators, to go to Editor, Manage Editor Features. This will open the Manage Editor Feature Profile window. By default, there will be no profile. Click on Create Profile and give it a name. You will then see a list of all the features in the Godot editor. The first section allows major editor features to be removed, such as 3D editor or scripting editor. Below in the main features is every class and node in Godot, which can be disabled as well. Click on a node and all of its properties and options will be listed in the extra items box. These can be individually disabled. Sharing a profile. To share profiles between editors, click on the export button. Save the custom profile somewhere as a .profile to use this in another editor. Open that editor's Manage Editor Feature Profiles window and click Import, then select the .profile file. This process is potentially cumbersome. However, if a large amount of computers need custom profiles as an alternative, you can enable self-contained mode for Godot, which allows putting all editor configuration in the same editor as the editor binary. See self-contained mode for details. Migrating to new version. Grading. Don't need to look at this page, or this page, or this page, or this page, this page, or this page. We can move on to just 2D. Godot includes a dedicated 2D render and 2D physics engine, as well as 2D specified features like tile maps, particles, and animation systems. This section covers most 2D specific topics in Godot. For 2D topics not covered in this section, see also 2D skeletons and 2D navigation overview for using physics in 2D. See physics. There is also a step-by-step tutorial on creating a 2D game in your first 2D game. 2D Introduction to 2D Canvas Layers Viewport. Yep. This is just a preview. Introduction to 2D. Godot's 2D game development tools include a dedicated 2D rendering engine, physics system, and features tailored specifically for creating 2D experiences. You can efficiently design levels with the tile map system, animate characters with 2D sprite or cutout animation, and leverage 2D lighting for dynamic scene illumination. The built-in 2D particle system allows you to create complex visual effects, and Godot also supports custom shaders to enhance your graphics. These features, combined with Godot's accessibility and flexibility, provide a solid foundation for creating engaging 2D games. 2D platformer demo available on the Asset Library. The page will show you the 2D workspace and how you can get to know it. Tip: if you would like to get an introduction to 3D, see Introduction to 3D. 2D workspace. You will use the 2D workspace to work with 2D scenes, design levels, or create user interfaces. To switch to the 2D workspace, you can either select a 2D node from the scene tree, or use the workspace selector located at the top edge of the editor. Similar to 3D, you can use the tabs below the workspace selector to change between currently open scenes to create a new one using the plus button. The left and right docks should be familiar from editor introduction. Below the scene editor selector is the main toolbar, and beneath the main toolbar is the 2D viewport. You can drag and drop compatible nodes from the file system dock to add them to the viewport as nodes. Dragging and dropping adds the dragged node as a sibling of the selected node. If the root node is selected, adds as a child. Keeping shift pressed when dropping adds the node as a child of the selected node. Holding Alt when dropping adds the node as a child of the root node. If Alt plus Shift is held when dropping, the node can be selected if applicable. Main toolbar. Some buttons in the main toolbar are the same as those in the 3D workspace. A brief explanation is given with the shortcut if the mouse cursor is hovered over a button for 1 second. Some buttons may have additional functionality if another key press is performed. A recap of main functionality of each button with its default shortcut is provided below from left to right. Select mode allows selection of nodes in the viewport. Left-clicking on a node in the viewport selects it. Left-clicking and dragging a rectangle selects all nodes within the rectangle's boundaries. Once released, holding Shift while selecting adds more nodes to selection. Clicking on a selected node while holding Shift deselects a node. In this mode, you can drag the selected nodes to move, press Ctrl to switch the rotation mode temporarily, or use the red circles to scale it. If multiple nodes are selected, only movement and rotation are possible. In this mode, rotation and scaling will not use the snapping options if snapping is enabled. Move mode enables move or translate mode for the selected nodes. See 2D viewport for more details. Rotate mode enables rotation mode for the selected nodes. See 2D viewport for more details. Scale mode enables scaling and displays scaling gizmos in both axes for the selected nodes. See 2D viewport for more details. Show list of selectable nodes at position clicked. As the description suggests, this provides a list of selectable nodes as the clicked position as a context menu, if there is more than one node in the clicked area. Rotation pivot sets the rotation pivot to rotate nodes around. An added node has its rotation pivot at x0, y0, by default with exceptions. For example, the default pivot for Sprite 2D is its center, if the center property is set to true. If you would like to change the rotation pivot for a node, click this button and choose a new location by left-clicking it. The node rotates considering this point. If you have multiple nodes selected, this icon will add a temporary pivot to be used commonly by all selected nodes. By pressing Shift and clicking this button will create the pivot at the center of selected nodes. If any of the snap options are enabled, the pivot will also snap them when dragged. Pan mode allows you to navigate in the viewport without accidentally selecting any nodes. In other modes, you can also hold space and drag with the left mouse button to do the same. Ruler mode. After enabling, click on the viewport to display the current global X and Y coordinates. Dragging from a position to another one measures the distance in pixels. If you drag diagonally, it will draw a triangle and show the separate distances in terms of x, y, and total distance to the target, including the angles to the axes in degrees. The R key activates the ruler. If snapping is enabled, it also displays the measurements in terms of grid count. Using ruler with snapping enabled. Use Smart Snap. Toggles Smart Snapping for move, rotate, and scale modes, and the rotation pivot. Customize it using the 3-dot menu next to the snap tools. Use Grid Snap. Toggles snapping to grid for move and scale mode. Rotation pivot and the ruler customize it to the 3-dot menu next to the snap tools. You can customize the grid settings so that the move mode, rotation mode, scale mode, ruler, and rotation pivot uses snapping. Use the 3-dot menus for this. Use rotation snap, toggles snapping using the configured rotation setting. Use scale snap, toggles snapping using the configured scaling step setting. Snap relatives toggles the usage of snapping based on the selected node's current transform values. For example, if the grids are set to 32 by 32 pixels and if the selected node is located at x1, y1, then enabling this option will temporarily shift the grids by x1, y1. Use Pixel Snap. Toggles the use of subpixels for snapping. If enabled, the position value will be integers. Disabling will enable subpixel movement as decimal values. For the runtime property, consider checking project settings, rendering 2D, snapping property for node TD nodes, and project settings GUI general snap controls to pixels for control nodes. Smart Snapping provides a set of options to snap to specific positions if they are enabled. Snap to parent snaps to parent's edges. For example, scaling a child control node while this is enabled will snap to the boundaries of the parent. Snap to node anchor. Snaps to the node's anchor. For example, if anchors of a control node is positioned at different positions, enabling this will snap to the sides of the corners of the anchor. Snap to node sides. Snaps to the node side, such as for the rotation pivot or anchor positioning. Snap to node center. Snaps to the node center, such as for rotation pivot or anchor positioning. Snap to other nodes. Snaps to other nodes while moving or scaling. Useful to align nodes in the editor. Snap to guides. Snaps to custom guides drawn using the horizontal or vertical ruler. More on this ruler and guides below. Configure snap opens the window shown above, offering a set of snapping parameters. Grid offset allows you to shift grids with respect to the origin. X and Y can be adjusted separately. Grid step. The distance between each grid in pixels X and Y can be adjusted separately. Primary line every. The number of grids in between to draw infinite lines as indication of main lines. Rotation offset. Sets the offset to shift rotational snapping. Rotation of step. Defines the snapping degree. E.g. 15 means the node will rotate and snap at multiples of 15 degrees if rotation snap is enabled and the rotation mode is used. Scale step. Determines the scaling increment factor. For example, if it is 0.1, it will change the scaling at 0.1 steps. If scaling snap is enabled, the scaling mode is used. Lock selected nodes. Control L locks the selected nodes, preventing selection and movement in the viewport. Clicking the button again for using Control Shift L unlocks the selected nodes. Locking nodes can only be selected in the scene tree. They can be easily identified by a padlock next to their node names in the scene tree. Clicking on the padlock also unlocks the nodes. Group selected nodes. Control G. This allows selection of the root node if any of the children are selected. Using Control G ungroups them. Additionally, clicking on the ungroup button in the scene tree performs the same action. Skeleton options provides options to work with skeleton 2D and bone 2D. Show bones toggles the visibility of bones for the selected node. Make 2D nodes from nodes converts the selected nodes into bone 2D. See also, to learn more about skeletons, see cutout animation. View menu provides options to control the viewport view. Since its options depend heavily on the viewport, it is covered in the 2D viewport section. Next to the view menu, additional buttons may be visible. In the toolbar image at the beginning of the chapter, an additional Sprite 2D button appears because a Sprite 2D is selected. This menu provides some quick actions and tools to work on a specific node or selection. For example, while drawing a polygon, it provides buttons to add, modify, or remove points. Coordinate system. In the 2D editor, unlike 3D, there are only two axes, X and Y. Also, the viewing angle is fixed. In the viewport, you can see two lines in two colors going across the screen indefinitely. Red for the x-axis and green for the y-axis. In Godot, going right and down are positive directions. Where these two lines intersect is the origin, x0, y0. A root node will have its origin at the position once added. Switching to the move or scale modes after selecting a node will display the gizmos at the node's offset position. The gizmos will point to the position to the positive directions of the x and y axes. In the move mode, you can drag the green line to move only in the y-axis. Similarly, you can hold the red line to move only in the x-axis. In the scale mode, the gizmos will have a square shape. You can hold and drag the green and red squares to scale the nodes in the y or x axes. Dragging in a negative direction flips a node horizontally or vertically. 2D viewport. The viewport will be the area you spend the most time in if you plan to design levels or user interfaces visually. Middle clicking and dragging the mouse will pan the view. The scroll bars on the right or bottom of the viewport also move the view. Alternatively, the G or space keys can be used. If you enable editor settings, editors panning, simple panning, you can activate panning directly with space only, without requiring dragging. The viewport has buttons on the top left. Center view centers the selected nodes in the screen, useful if you have a large scene with many nodes, and you want to see the nodes selected in the scene tree. Next to it are the zoom controls. Zoom out zooms minus zooms out, plus zooms in, and clicking on the number with the percentage defaults to 100. Alternatively, you can use middle mouse scrolling in zoom in, scroll up, and out, scroll down. The black parts at the viewport's left and top edges are the rulers. You can use them to orient yourself in the viewport. By default, the rulers will display the pixel coordinates in the viewport. Numbered at 100 pixels, changing the zoom factor will change the shown values. Enabling grid snap or changing the snapping options will update the ruler scaling and the shown values. You can also create multiple custom guides to help you make measurements or line nodes with them. If you have at least one node in the scene, you can create guides by dragging from the horizontal or vertical ruler towards the viewport. A purple guide will appear showing its position, and will remain there when you release the mouse. You can create both horizontal and vertical guides simultaneously by dragging from the gray square at the ruler's intersection. Guides can be repositioned by dragging them back to their respective rulers, and they can be removed by dragging them all the way back to the ruler. You can also enable snapping to the created guides using the Smart Snap menu. Note: if you cannot create a line or do not see previously created guides, make sure that they are visible by checking the View menu of the viewport. Y toggles their visibility by default. Also, make sure you have at least one node in the scene. Depending on the tool chosen in the toolbar, left-clicking will have a primary action in the viewport. For example, the Select mode will select the left-clicked node in the viewport. Sometimes left-clicking can be combined with a modifier, e.g. Control or Shift, to perform secondary actions. For example, keeping Shift pressed while dragging a node in the Select or Move modes will try to snap the node in a single axis while moving. Right-clicking in the viewport provides two options to create a node or instantiate a scene at the chosen position. If at least one node is selected, right-clicking also provides the option to move the selected nodes to this position. Viewport has a View menu, which provides several options to change the look of the viewport. Grid allows you to show grids all the time while using snapping or not at all. You can also toggle them with the provided option. Show Helpers toggles the temporary display of an outline of the node with the previous transform properties, position, scaling, or rotation, if a transform operation has been initiated. For control nodes, it also shows the sizing parameters, useful to see the deltas. Show Rulers toggles the visibility of horizontal and vertical rulers. See 2D Viewport, more on rulers. Show Guides toggles the visibility of created guides. See 2D Viewport for on how to create them. Show Origin toggles the display of the green and red origin lines drawn at x0, y0. Show Viewport toggles the visibility of the game's default viewport, indicated by an indigo colored rectangle. It is also the default window size on desktop platforms, which can be changed by going to Project Settings, Display Window size, and setting viewport width and viewport height. Gizmos toggles the visibility of position, shown with cross icon. Lock shown with padlock, groups shown with two squares, and transforms shown with green and red lines. Indicators. Center selection, the same as the center view button inside the viewport, centers the selected nodes in the view. F is the default shortcut. Frame to selection. Similar to center selection, but also changes the zoom factor to fit the contents in the screen. Shift F is the default shortcut. Clear guides. Deletes all guides from the screen. You will need to create them if you plan to use them later. Preview canvas scale. Toggles the preview for scaling of canvas in the editor. When the zoom factor or view of the viewport changes, useful to see how the controls will look after scaling and moving without running the game. Preview theme allows to choose from the available themes to change the look of control items in the editor without requiring to run the game. Node 2D and Control Node. Canvas item is the base node for 2D. Node 2D is the base node for 2D game objects, and Control is the base node for everything GUI. For 3D, Godot uses the Node 3D node, displaying 3D nodes in 2D. It is possible to display 3D nodes in 2D in a 2D scene by using a sub-viewport. You can see this in the demo 3D in 2D viewport. What is the... Oh, Homestuck. Announcement. One more day, Jen Carcat makes plush campaigns close tomorrow. Okay. Nothing too important. many we got? 1, 2, 3, 4, 5. Canvas layers, viewport, and canvas items. Canvas items is the base for all 2D nodes, be it regular 2D nodes such as Node 2D or Control, both inherit from canvas item. You can arrange canvas items in trees. Each item will inherit its parent transform. When the parent moves, its children move too. Canvas item nodes and nodes inheriting from them are direct or indirect children of a viewport that displays them. The viewport's property viewport.canvas_transform allows to display a custom transform 2D transform to the canvas item hierarchy it contains. Nodes such as camera 2D work by changing that transform. To achieve effects like scrolling, manipulating the canvas transform property is more efficient than moving the root canvas item and the entire scene with it. Usually, though, we don't want everything in the game or app to be subject to the canvas transform. For example, parallax backgrounds that move slower than the rest of the stage. UI, think of the user interface. UI or head-up display, HUD superimposed on our view of the game. World, we want a life counter, score display, and other elements to retain their screen positions even when our view of the game world changes. Transitions. We may want visual effects used for transitions, fades, blends, to remain at a fixed screen location. How to solve these problems in a single scene tree. Canvas layers. The answer is canvas layers, which is a node that adds a separate 2D rendering layer for all its children and grandchildren. Viewport children will draw by default at layer 0, while a canvas layer will draw at any numeric layer. Layers with a greater number will be drawn above those with a smaller number. Canvas layers also have their own transform, and do not depend on the transform of other layers. This allows the UI to be fixed in screen space while our view of the game world changes. An example of this is creating a parallax background. This can be done with a canvas layer at layer -1. The screen with the points, life counter, and pause button can also be created at layer 1. Here's a diagram of how it looks. Canvas layers are independent of the tree order, and they only depend on their layer number, so they can be instantiated when needed. Note, canvas layers aren't necessary to control the drawing order of nodes. The standard way of ensuring that a node is correctly drawn in front or behind others is to manipulate the order of the nodes in the scene panel. Perhaps counterintuitively, the topmost nodes in the scene panel are drawn on behind lower ones in the viewport. 2D nodes also have the canvas item Z index, property for controlling their drawing order. Viewport and canvas transforms. Introduction. This is an overview of the 2D transforms going on for nodes from the moment they draw their content locally to the time they are drawn onto the screen. This overview discusses very low level details of the engine. The goal of this tutorial is to teach a way for feeding input events to the input with the position in the correct coordinate system. A more extensive description of all coordinate systems and 2D transforms is available in 2D coordinate and systems and 2D transforms. Canvas transform. As mentioned in the previous tutorial, canvas layers, every canvas item node, remember that Node 2D and control-based nodes use canvas item as their common root, will reside in a canvas layer. Every canvas layer has a transform, translation, rotation, scale, etc. that can be accessed as a transform 2D. Also covered in the previous tutorial, nodes are drawn by default in layer 0 in the built-in canvas. To put nodes in a different layer, a canvas layer node can be used. Global canvas transform. Viewports also have a global canvas transform, also a transform 2D. This is the master transform and affects all individual canvas layer transforms. Generally, this is primarily used in Godot's canvas item editor. Stretch transform. Finally, viewports have a stretch transform, which is used when resizing or stretching the screen. This transform is used internally as described in multiple resolutions, but can also be manually set on each viewport. Input events are multiplied by the transform, but lack the ones above. To convert input event coordinates to local canvas item coordinates, the canvas item make input local function was added for convenience. Window transform. The root viewport is a window in order to scale and position the window's content as described in multiple resolutions. Each window contains a window transform. It is, for example, responsible for the black bars at the window's sides so that the viewport is displayed with a fixed aspect ratio. Transform order. To convert a canvas item local coordinate to an actual screen coordinate, the following chain of transforms must be applied. Transform functions. The above graphic shows some available transform functions. All transforms are directed from right to left, which means multiplying a transform with a coordinate results in the coordinate system further to the left. Multiplying the affine inverse of a transform results in the coordinate system further to the right. Finally, then, to convert a canvas item local coordinates to the screen coordinates, just multiply the following order. Keep in mind, however, that it is generally not desired to work with screen coordinates. The recommended approach is to simply work in canvas coordinates to allow automatic screen resolution resizing to work properly. Feeding custom input events. It is often desired to feed custom input events to the game. With the above knowledge, to correctly do this in the focused window, it must be done the following way. 2D lights and shadows introduction. By default, 2D scenes in Godot are unsaved with no lights and shadows visible. While this is fast to render, unshaded scenes can look bland. Godot provides the ability to use real-time 2D lighting and shadows, which can greatly enhance a sense of depth in your project. No 2D lights or shadows seen as unshaded. 2D lights enabled without shadows. 2D lights and shadows enabled. Nodes. There are several nodes involved in a complete 2D lighting setup. Canvas modulate. To darken the rest of the scene, point light 2D for omnidirectional or spotlights, directional light 2D for sunlight or moonlight, light ocular 2D for light shadow casters. Other 2D nodes that receive lighting, such as sprite 2D or tile map layer. Canvas modulate is used to darken the screen by specifying a color that will act as a base ambient color. This is the final lighting color in areas that are not reached by any 2D light without a canvas modulate node. The final scene would look too bright, as 2D lights would only brighten the existing unshaded appearance, which appears fully lit. Sprite 2Ds are used to display the textures for the light blobs, the background, and for the shadows, and for the shadow casters. Point light 2Ds are used to light the scene. The way a light typically works is by adding a selected texture over the rest of the scene to simulate lighting. Light ocular 2Ds are used to tell the shader which parts of the scene cast shadows. These occluders can be placed as independent nodes or can be part of a tile map layer node. The shadows appear only on areas covered by the point light 2D, and their direction is based on the center of the light. Hi! What's up? You unmuted yourself, or undeafened yourself. Hello? Are you there? I just noticed that it's really quiet. So I'ma turn it up. That maybe a bit down, but yeah, it was really quiet for you guys. Ethan, are you there? I guess not. Yeah. Note, the background color does not receive any lighting. If you want a light to be cast on the background, you need to add visual representation for the background, such as a Sprite 2D. Sprite 2D's region properties can be helpful to quickly create a repeated background texture, but remember to also set texture repeat to enabled in the Sprite 2D's properties. Point lights. Point lights, also called positional lights, are the most common element in 2D lighting. Point lights can be used to represent light from torches, fire, projectiles, etc. Point light 2D offers the following properties to tweak in the inspector. Texture. The texture to use as a light source. The texture's size determines the size of the light. The texture may have an alpha channel, which is useful when using light Light 2D's mixed blend mode, but it is not required if using the add, default, or subtract blend modes. Offset. The offset for the light texture, unlike when you move the light node, changing the offset does not cause shadows to move. Texture scale. The multiplier for the light size, higher values will make the light extend out further. Larger lights have a higher performance cost as they affect more pixels on screen, so consider this before increasing a light size. Height. The light's virtual height with regards to normal mapping by default. What? Where was I? Oh, by default, the light is very close to surfaces receiving lights. This will make lighting hardly visible if normal mapping is used, so consider increasing their value. Adjusting the light's height only makes a visible difference on surfaces that use normal mapping. If you don't have a pre-made light texture to use in a light, you can use the neutral point light texture, right-click, save image as, neutral point light texture. If you need different fall off, you can procedurally create a texture by assigning a new gradient texture 2D on the light's texture property. After creating the resource, expand its fill section and set the fill mode to radial. You will then have to adjust the gradient yourself to start from opaque white to transparent white and move its starting location to be in the center. Directional light. Directional lighting is used to represent sunlight or moonlight. Light rays are casted parallel to each other as if the sun or moon was infinitely far away from the surface that is receiving the light. Directional light 2D offers the following properties. Height. The light's virtual height with regards to normal mapping, 0 parallel to surfaces, 1 perpendicular to surfaces. By default, the light is fully parallel with the surfaces receiving lights. This will make lighting hardly visible if normal mapping is used, so consider increasing this value. Adjusting the light's height only makes a visual difference on surfaces that use normal mapping. Height does not affect shadows' appearance. Max distance. The maximum distance from the camera center objects can be before their shadows are culled in pixels. Decreasing this value can prevent objects located outside the camera from casting shadows, while also improving performance. Camera 2D is not taken into account by max distance, which means that at higher zoom values, shadows will appear to fade out sooner when zooming into a given point. Note, directional shadows will appear to be infinitely long, regardless of the value of the height property. This is a limitation of the shadow rendering method used for 2D lights in Godot. To have directional shadows that are not infinitely long, you should disable shadows in the directional light 2D and use a custom shader that reads from the 2D sign distance field instead. This distance field is automatically generated from light occluder 2D nodes present in the scene. Hello, Naya. Welcome home. Oh, bye. Ethan. Are you there? Or are you still gone? I think he's still gone. Or something. I'm not sure what he's doing. I need to do something. Filters. Edit filters. On my noise suppression, limiter, gain. I have it set to 2, but what if I increase it, what does that do? I think it, okay, yeah, that's way too loud. 20, how's that? 20 is a bit too loud. How about 15? Is 15 good? 15 looks good. Alright. Maybe not. 10? 10. Alright, 10. No better. Eh. Okay. Yeah, it was a bit too quiet. Common light properties. Both point light 2D and directional light 2D offer common properties, which are part of the light 2D base class. Enabled allows toggling the light's visibility. Unlike hiding the light node, disabling this property will not hide the light's children. Editor only. If enabled, the light is only visible within the editor. It will be automatically disabled in the running project. Color. The light's color. Energy. The light's intensity multiplier. Higher values result in a brighter light. Blend mode. The blending formula used for light computations. The default add is suited for most use cases. Subtract can be used for negative lights, which are not physically accurate but can be used for special effects. The mix blend mode mixes the value of pixels corresponding to the light's texture with the values of pixels under it by linear interpolation. Range Z min, the lowest Z index affected by the light. Range Z max, the highest Z index after the light. Range layer min, the lowest visual layer affected by the light. Range layer max, the highest visual layer affected by the light. Range item col mask controls which nodes receive light from this node, depending on the other nodes' enabled visual layers. Occluder light mask. This can be used to prevent certain objects from receiving light. Setting up shadows. After enabling the shadow enabled property in the point light 2D or directional light 2D node, you will not see any visual difference initially. This is because no nodes in your scene have any occluders yet, which are used as a basis for shadow casting. Balls. Oh, he's deafened now. Great. For shadows to appear in the scene, light occluder 2D nodes must be added to the scene. These nodes must have occluder polygons that are designed to match the sprite's outline, along with their polygon resource, which must be set to have any visual effect. Light occluder 2D nodes have two properties. SDF collision. If enabled, the occluder will be part of a real-time generated sign distance field that can be used in custom shaders. When not using custom shaders that read from this SDF, enabling this makes no visual difference and has no performance cost, so this is enabled by default for convenience. Occluder light mask. This is used in tandem with point light 2D and directional light 2D's shadow item col mask property to control which objects cast shadows for each light. This can be used to prevent specific objects from casting shadows. There are two ways to create light occluders. Automatically generate a light occluder. Occluders can be created automatically from Sprite 2D nodes by selecting the node, clicking the Sprite 2D menu at the top of the 2D editor, then choosing Create Light Occluder 2D Sibling. In the dialog that appears, an outline will surround your sprite's edges. If the outline matches the sprite's edges closely, you can select OK. If the outline is too far away from the sprite's edges or is eating into the sprite's edges, adjust Grow Pixels and Shrink Pixels, then click Update Preview. Repeat this operation until you get satisfactory results. Manually drawing a light occluder. Create a light occluder 2D node, then select the node and click the plus button at the top of the 2D editor. When asked to create a polygon resource, answer yes. You can then start drawing an occluder polygon by clicking to create new points. You can remove existing points by right-clicking them, and you can create new points from the existing line by clicking on the line, then dragging. The following properties can be adjusted on the 2D lights that have shadows enabled. Color. The color of shaded areas by default. Shaded areas are fully black, but this can be changed for artistic purposes. The color's alpha channel controls how much the shadow is tinted by the specific color. Filter. The filter mode is used for shadows. The default none is the fastest to render, and is well suited for games with a pixel art aesthetic. Due to its blocky visuals, if you want a soft shadow, use PCF5. Instead, PCF 13 is even softer, but is the most demanding to render. PCF 13 should only be used for a few lights at once due to its high rendering cost. Item col mask controls which light occluder 2D nodes cast shadows depending on their respective occluder light mask properties. Note: lighting and shadow resolution in pixel art games. The engine computes 2D lighting and shadows on the viewport's pixel resolution, not at the source texture's pixel resolution. The appearance of lights and shadows depends on your window or viewport resolution, not on the resolution of individual sprite textures. If you create a pixel art game and want pixelated or blocky lighting and shadows that match your art style, nearest texture filtering will not achieve this effect. Nearest filtering affects only how the engine samples textures. It will not change how the engine renders lighting and shadows. To achieve pixelated lighting and shadows, use a custom shader to modify light vertex and shadow vertex as snap light sampling to a pixel grid. The following shader snaps lighting to a grid using the floor function. This works by dividing the position by pixel size to convert to grid space, using the floor to round down to the nearest grid point, then multiplying back to convert to screen space. The result forces the engine to sample lighting from discrete grid positions, which creates the pixelated effect. For more information on canvas item shaders, see canvas item shaders. Hard shadows. Soft shadows. PCF 13, filter smooth 1.5. Soft shadows with streaking artifacts due to their smooth being too high. PCF 5, filter smooth 4. Interesting. Normal and specular maps. Normal maps and specular maps can greatly enhance the sense of depth of your 2D lighting. Similar to how these work in 3D rendering, normal maps can help make lighting look less flat by varying its intensity depending on the direction of the surface receiving light on a per pixel basis. Specular maps further help improve visuals by making some of the light reflect back to the viewer. Both point light 2D and directional light 2D support normal mapping and specular mapping. Normal and specular maps can be assigned to any 2D element, including nodes that inherit from node 2D or control. A normal map represents the direction in which each pixel is pointing towards. This information is then used by the engine to correctly apply lighting to 2D surfaces in a physically plausible way. Normal maps are typically created from hand-painted height maps, but they can also be automatically generated from other textures. A specular map defines how much each pixel should reflect light, and in which color. If the specular map contains color, brighter values will result in a brighter reflection at that given spot in the texture. Specular maps are typically created with manual editing, using the diffuse texture as a base. Tip: if you don't have normal or specular maps for your sprites, you can generate them using the free and open source Legter tool. Huh. I will have to take a look at that. To set up normal maps and or specular maps on a 2D node, create a new canvas texture resource for the property that draws the node's texture. For example, on a sprite 2D. Creating a canvas texture resource for a sprite 2D node. Expand the newly created resource. You can find several properties you will need to adjust. Diffuse texture. The base color texture is the property. Load the texture you're using for the sprite itself. Normal map texture. The normal map texture in this property. Load a normal map texture you've generated from a height map. See the tip above. Specular texture. The specular map texture, which controls the specular intensity of each pixel on the diffuse texture. The specular map is usually grayscale, but it can also contain color to multiply the color of reflections accordingly. In this property, load a specular map texture you've created. See the tip above. Specular color. The color multiplier for specular reflections. Specular shininess. The specular exponent to use for reflections. Lower values will increase the brightness of reflections and make them more diffuse, while higher values will make reflections more localized. Higher values are more suited for wet-looking surfaces. Texture filter can be set to override the texture filtering mode, regardless of what the node's property is set to, or the rendering texture canvas texture's default texture filter project setting. Texture repeat can be set to override the texture filtering mode, regardless of what the node's property is set to, or the rendering texture's canvas texture's default texture repeat or project setting. Project setting, not just project setting. After enabling normal mapping, you may notice that your lights appear to be weaker. To resolve this, increase the height property on your 2D point light 2D and directional light 2D nodes. You may also want to increase the light's energy property slightly to get closer to how your lighting's intensity looked prior to enabling normal mapping. Using additive sprites as faster alternative to 2D lights. If you run into performance issues when using 2D lights, it may be worth replacing some of them with Sprite 2D nodes that use additive blending. This is particularly suited for short-lived dynamic effects such as bullets or explosions. Additive sprites are much faster to render since they don't need to go through a separate rendering pipeline. Additionally, it is possible to use this approach with Animated Sprite 2D or Sprite 2D plus Animation Player, which allows for animated 2D lights to be created. However, additive sprites have a few downsides compared to 2D lights. The blending formula is inaccurate compared to the actual 2D lighting. This is usually not a problem in sufficiently lit areas, but this prevents additive sprites from correctly lighting up areas that are fully dark. Additive sprites cannot cast shadows since they are not lights. Additive sprites ignore normal and specular maps used on other sprites. To display a sprite with additive blending, create a sprite 2D node and assign a texture to it. In the inspector, scroll down to Canvas Item Material Selection, unfold it, and click the drop-down text to the material property. Choose New Canvas Item Material. Click the newly created material to edit it, then set Blend Mode to Add. Work in progress. Okay. 2D meshes. Introduction. In 3D, meshes are used to display the world. In 2D, they are rare as images and are used more often. Godot's 2D engine is a pure two-dimensional engine, so it can't really display 3D meshes directly, although it can be done via viewport and viewport texture. See also, if you are interested in displaying 3D meshes on a 2D viewport, see the using sub-viewport as a texture tutorial. 2D meshes are meshes that contain two-dimensional geometry. Z can be omitted or ignored. Instead of 3D, you can experiment creating them yourself using Surface Tool from code and displaying them in a Mesh Instance 2D node. Currently, the only way to generate a 2D mesh within the editor is by either importing an OBJ file as a mesh or converting it from a Sprite 2D. Optimizing pixel drawn. This workflow is useful for optimizing 2D drawing in some situations. When drawing large images with transparency, Godot will draw the whole quad to the screen. The large transparent areas will still be drawn. This can affect performance, especially on mobile devices when drawing very large images, generally screen-sized, or layering multiple images on top of each other with large transparent areas. For example, when using parallax background, converting to a mesh will ensure that the only opaque parts will be drawn and the rest will be ignored, converting Sprite 2Ds to 2D meshes. You can take advantage of this optimization by converting a Sprite 2D to a Mesh Instance 2D. Start with an image that contains large amounts of transparency on the edges like this tree. Put it in a Sprite 2D and select Convert Mesh Instance 2D from the menu. A dialog will appear showing a preview of how the 2D mesh will be created. The default values are good enough for many causes, but you can change growth and simplification according to your needs. Finally, pushing the Convert 2D Mesh button and your Sprite 2D will be replaced. How many we got? 3? 2D Sprite Animation. Introduction. In this tutorial, you'll learn how to create 2D animation characters with the Animated Sprite 2D class and the Animation Player. Typically, when you create or download an animated character, it will come in one of two ways, as an individual image or as a single sprite sheet containing all the animation's frames. Both can be animated in Godot and the Animation Sprite 2D class. First, we'll use Animated Sprite 2D to animate a collection of individual images. Then we will animate a sprite sheet using this class. Finally, we will learn another way to animate a sprite sheet with Animation Player and the animation property of Sprite 2D. Note, art for the following examples by opengameart.org and okay, just that. Individual images and the animated Sprite 2D. In this scenario, you have a collection of images, each containing one of your character's animation frames. For this example, we will use the following animation. You can download the images here. Unzip the images and place them in your projects folder. Set up the scene tree with the following nodes. The root node could also be area 2D. We've done this before. We've done all this before. We don't need to do it all again. Work in progress. 2D particle system. Intro. Particle systems are used to simulate complex physical effects such as sparks, fire, magic particles, smoke, mist, etc. The idea is that a particle is emitted at a fixed interval with a fixed lifespan, or lifetime. During its lifetime, every particle will have the same behavior. What makes each particle different from the rest and provides a more organic look is the randomness associated with each parameter. In essence, creating a particle system means setting base physics parameters and then adding randomness to them. Particle nodes. Godot provides two different nodes for 2D particles: GPU particles 2D and CPU particles 2D. GPU particles 2D is more advanced and uses the GPU to process particle effects. CPU particles 2D is a CPU-driven option with near future parity with GPU particles 2D, but lower performance when using large amounts of particles. On the other hand, CPU particles 2D may perform better on low-end systems or in GPU bottlenecked situations. While GPU particles 2D is configured via a particle process material and optionally with a custom shader, the matching options are provided via node properties in CPU particles 2D, with the exception of the trail settings. Going forward, there are no plans to add new features to CPU Particles 2D, though pull requests to add features already in GPU Particles 2D will be accepted. For that reason, we recommend using GPU Particles 2D unless you have an explicit reason not to. You can convert a CPU Particles 2D node into a GPU Particles 2D node by clicking on the node in the scene tree, selecting the 2D workspace, and selecting CPU Particles 2D. Convert the GPU Particles 2D in the toolbar. It is also possible to convert a GPU Particles 2D node in a node to a CPU Particles 2D node. However, there may be issues if you use GPU-only features. The rest of this tutorial is going to use the GPU Particles 2D node. First, add a GPU Particles 2D node to your scene. After creating that node, you will notice that only a white dot was created, and that there is a warning icon next to your GPU Particles 2D node in the scene dock. This is because the node needs a particle process material to function. Particle process material. To add a process material to your particles node, go to process material. In your inspector panel, click on the box next to material, and from the drop-down menu, select new particle process material. Your GPU particles 2D node should now be emitting white points downward. Texture. A particle system can use a single texture or an animation flipbook. A flipbook is a texture that contains several frames or animation that can be played back. Played back or chosen at random during a mission. This is equivalent to a sprite sheet for particles. The texture is set to the texture property. Using an animation flipbook. Particle flipbooks are suited to reproduce complex effects such as smoke, fire, explosions. They can also be used to introduce random texture variation by making every particle use a different texture. You can find existing particle flipbook images online or pre-render them using external tools such as Blender or EmberGen. Example of particle system that uses a flipbook texture. Using an animation flipbook requires additional configuration compared to a single texture. For demonstration purposes, we will use this texture with 5 columns and 7 rows. Right-click and choose Save As. To use an animation flipbook, we must use a new canvas material in the material section of the GPU Particles 2D or CPU Particles 2D node. Creating a canvas material at the bottom of the Particles node inspector. In this canvas item material, enable particle animation and set H frames and V frames to the number of columns and rows present in your flipbook texture. Configuring the canvas item material in for the example flipbook texture. Once this is done, the animation section in the particle process material for GPU Particles 2D or in the CPU Particles 2D inspector will be effective. Tip: if your flipbook texture has a black background instead of a transparent background, you will also need to set the blend mode to add instead of mix for correct display. Alternatively, you can modify the texture to have transparent background in an image editor. In GIMP, this can be done using the color to alpha menu. Time parameters. Lifetime. The time in seconds that every particle will stay alive. When lifetime ends, a new particle is created to replace it. Lifetime 0.5, lifetime 4. One shot. When enabled, GPU Particles 2D node will emit all of the particles once and never again. pre-process. Systems begin with 0 particles emitted, then start emitting. This can be an inconvenience when loading a scene, and systems like a torch, mist, etc. begin emitting the moment you enter. Pre-process is used to let the system process a given number of seconds before it is actually drawn the first time. Speed scale. The speed scale has a default value of 1 and is used to adjust the speed of a particle system. Lowering the value will make the particles slower, will increase the value, and will make the particles much faster. Explosiveness. Hi, welcome back.
Well,
How's editing going?
oh, I got tired, so I quit a minute ago.
So what you doing? Absolutely nothing. Got it.
Yeah.
Yeah, let's see. How much shit do we still need to go through in here? So we got through best practices, troubleshooting, editor introduction, migrating to a new version 2D. We're currently in 2D.
I have a cat in the room.
Oh, fun. The other sections, we have 3D, animation, assets, pipeline, audio, export, file and data, I/O, internalization, input handling, math, navigation, networking, performance, physics, platform-specific plugins, rendering, scripting, shaders, user interface, and XR. So there's still quite a bit that I need to get through for this. Although not all of this is as long as some other sections, and not all of it I will actually read because I don't need to. Explosiveness. If lifetime is 1 and there are 10 particles, it means a particle will be emitted every 0.1 seconds. The explosiveness parameter changes this and forces particles to be emitted altogether. Ranges are 0. Emit particles at regular intervals, default value. 1. Emit all particles simultaneously. Values in the middle are also allowed. This feature is useful for creating explosions or sudden bursts of particles. Randomness. All physics parameters can be randomized. Random values range from 0 to 1. The formula to randomize a parameter is that. Fixed FPS. The setting can be used to set the particle system to render at a fixed FPS. For instance, changing the value to 2 will make the particles render at 2 frames per second. Note, this does not slow down the particle system itself. Note, Godot 4.3 does not currently support physics interpolation for 2D particles. As a workaround, disable physics interpolation for the particles node by setting node physics interpolation mode at the bottom of the inspector. Fract delta. Setting frac delta to true results in fractional delta calculation, which has a smoother particles display effect. This increases smoothness stems from higher accuracy. The difference is more noticeable in systems with high randomness or fast-moving particles. It helps maintain the visual consistency of the particle system, making sure that each particle motion aligns with its actual lifespan. Without it, particles might appear to jump or move more than they should in a single frame. If they are emitted at a point within the frame, the greater accuracy has a performance trade-off, particularly in systems with a higher amount of particles. Drawing parameters. Visibility rect. The visibility rectangle controls the visibility of the particles on screen. If this rectangle is outside of the viewport, the engine will not render the particles on screen.
I'm leaving. Yeah.
Alright. I'm not surprised. Honestly, if he's going to come in here, he should probably actually want to interact with what's going on instead of just hang out in the VC. But he can do whatever he wants. Where was I? On the screen. Oh, the rectangle's W and H properties respectively control its width and height. its width and its height. The X and Y properties control the position of the upper left corner of the rectangle relative to the particle emitter. You can have Godot generate a visibility and rect automatically using the toolbar above the 2D view. To do so, select the GPU Particles 2D node and click Particles Generate Visibility Rect. Godot will simulate the Particles 2D node emitting particles for a few seconds and set the rectangle to fit the surface the particles take. You can control the emit duration with the generate time seconds option. The maximum value is 25 seconds. If you need more time for your particles to move around, you can temporarily change the pre-process duration on the Particles 2D node. Local coordinates. By default, this option is off. It means that the space that particles are emitted to is global and not relative to the node. If the node is moved, existing particles are not moved with it. If enabled, particles will emit to local space, meaning that if the node is moved, already emitting particles are also affected. Draw order. This controls the order in which individual particles are drawn. Index means particles are drawn according to their emission order. Default. Lifetime means they are drawn in order of remaining lifetime. Particle process material settings. For information on the settings in the particles process material, see this page. I need to go and use the bathroom real quick. I'll be back. Alright. Particle process material 2D usage. Process material properties. The properties in this material control how particles behave and change over their lifetime. A lot of them have min, max, and curve values that allow you to fine-tune their behavior. The relationship between these values is this. When a particle is spawned, the property is set to a random value between min and max. If min and max are the same, the value will always be the same for every particle. If the curve is also set, the value of the property will be multiplied by the value of the curve at the current point in a particle's lifetime. Use the curve to change a property over the particle lifetime. Very complex behavior can be expressed this way. Note, this page covers how to use particle process material for 2D scenes specifically. For information on how to use it in a 3D scene, see process material properties. Lifetime randomness. The lifetime randomness property controls how much randomness to apply to each particle's lifetime. A value of 0 means there is no randomness at all, and all particles live for the same amount of time set by the lifetime property. What was the... A value of 1 means that the particle's lifetime is completely random within the range of 0 to lifetime. Particle flags. Spawn angle. Determines the initial angle of the particle in degrees. This parameter is mostly useful randomized. Velocity direction. This is the base direction at which particles emit. The default is vector 3100, which makes particles emit to the right. However, with the default gravity setups, particles will go straight down. For this property to be noticeable, you will need the initial velocity greater than 0 here. We set the initial velocity to 4. You'll notice that the particles emit toward the right, then go down because of gravity. Spread. The parameter is the angle in degrees, which will be randomly added in either direction to the base direction. A spread of 180 will emit in all directions. plus minus 180. For spread to do anything, the initial velocity parameter must be greater than 0. Flatness. This property is only useful for 3D particles. Initial velocity. Initial velocity is the speed at which particles will be emitted in pixels per second. Speed might later be modified by gravity or other accelerations, as described further below. Animated velocity. Angular velocity. Angular velocity is the speed at which particles rotate around their center in degrees per second. Orbit velocity. Orbit velocity is used to make particles turn around their center. Accelerations. Gravity. The gravity applied to every particle. Linear acceleration. The linear acceleration applied to each particle. Radial acceleration is the if the acceleration is positive, particles are accelerated away from the center. If negative, they are absorbed towards it. Tangential acceleration. The acceleration will use the tangent vector to the center. Combining with radial acceleration can do nice effects. Damping. Damping applies friction to the particles, forcing them to stop. It is especially useful for sparks or explosions, which usually begin with a higher linear velocity and then stop as they fade. Display scale determines the initial scale of the particles. Color curves. Color used to change the color of the particles being emitted. Hue saturation. The variation value sets the initial hue variation applied to each particle. The variation random value controls the hue variation randomness ratio. Animation. Note, particle flipbook animation is only effective if the canvas item material used on the GPU Particles 2D or CPU Particles 2D node has been configured accordingly. To set up the particle flipbook for linear playback, set the speed minimum and speed maximum values to 1. Setting up particle animation for playback during the particle's lifetime. By default, looping is disabled if the particle is done playing before its lifetime ends. The particle will keep using the flipbook's last frame, which may be fully transparent depending on how the flipbook texture is assigned. If looping is enabled, the animation will loop back to the first frame and resume playing. Depending on how many images your sprite sheet contains and for how long your particle is alive, the animation might not look smooth. The relationship between particle lifetime animation speed and number of images in the sprite sheet is this. At an animation speed of 1, the animation will reach the last image in the sequence just as the particle's lifetime ends. Animation FPS equals the number of images over lifetime. If you wish the particle flipbook to be used as a source of random particle textures for every particle, keep the speed values at 0 and set offset max to 1 instead. Setting up the particle animation for random offset on emission. Note that GPU Particles 2D nodes fixed FPS also affects animation playback. For smooth animation playback, it's recommended to set it to 0 so that the particle is simulated on every rendered frame. If this is not an option for your use case, set fixed FPS to be equal to the effect frame rate used by the flipbook animation. See above for the formula. Emission shapes. Particle process materials allows you to set an emission mask, which dictates the area and direction in which particles are emitted. These can be generated from textures in your project. Ensure that a particle process material is set and the GPU Particles 2D node is selected. A particles menu should appear in the toolbar. Open it and select Load Emission Mask. Then select the texture. Then select which texture you want to use as your mask. A dialog box with several settings will appear. Emission mask. 3 types of emission masks can be generated from a texture. Solid pixels. Particles will spawn from any area of the texture, excluding transparent areas. Border pixels. Particles will spawn from the outer edges of a texture. Directed border pixels. Similar to border pixels, but adds extra information to the mask to give particles the ability to emit away from the borders. Note that an initial velocity will need to be set in order to utilize this. Emission colors. Capture from pixel will cause the particle to inherit the color of the mask at their spawn points. Once you click OK, the mask will be generated and set the particle process material under spawn and then position. All the values within this selection have been automatically generated by the Load Emission Mask menu, so they should generally be left alone. Note, an image should not be added to point texture or color texture directly. The Load Emission Mask menu should always be used instead. Customizing the process material. If you need to change or implement new behaviors in shader code, you can do so by converting the current particle process material to a shader material. Existing properties are preserved by the conversion process. Features that are enabled will also affect what's present in the converted shader code. To do so, right-click on the material in the file system dock and choose Convert to Shader Material. You can also do so by right-clicking on the property holding a reference to the material in the inspector. 2D initializing. Godot support initializing 3D rendering. This is also covered in the 3D anti-aliasing page. Introduction. Due to their limited resolution, scenes rendered in 2D can exhibit anti-aliasing artifacts. These artifacts usually manifest in the form of a staircase effect on geometry edges, and are most noticeable when using nodes such as Line 2D, Polygon 2D, or Texture Progress Bar. Custom drawing in 2D can also have aliasing artifacts for methods that don't support anti-aliasing. In the example below, you can notice how edges have a blocky appearance. Yep, that is correct. Image is scaled by 2x with nearest neighbor filtering to make aliasing more noticeable. To combat this, Godot supports several methods of enabling anti-aliasing on 2D rendering. Anti-aliasing property in Line 2D and custom drawing. This is the recommended method as it has a lower performance impact in most cases. Line 2D has a anti-aliasing property which you can enable in the inspector. Also, several methods for custom drawing in 2D support an optional anti-aliased parameter, which can be set to true when calling the function. These methods do not require MSAA to be enabled, which makes their baseline performance cost low. In other words, there is no permanent added cost if you're not drawing any anti-aliasing geometry at some point. The downside of these anti-aliasing methods is that they work by generating additional geometry. If you're generating complex 2D geometry that's updated every frame, this may be a bottleneck. Also, Polygon 2D Texture Progress Bar. And several custom drawing methods don't feature anti-alias property. For these nodes, you can use the 2D multi-sample anti-aliasing instead. Multi-sample anti-aliasing MSAA. This is only available in the Forward Plus and mobile renderers, not the compatibility renderer. Before enabling MSAA in 2D, it's important to understand what MSAA will operate on. MSAA in 2D follows similar restrictions as in 3D. While it does not introduce any blurriness, its scope of application is limited. The main applications of 2D MSAA are geometry edges, such as lines and polygon rendering, sprite edges only for pixels touching one of the texture's edges. This works for both linear and nearest neighbor filtering. Sprite edges created using transparency on the image are not affected by MSAA. The downside of MSAA is that it only operates on edges. This is because MSAA increases the number of coverage samples, but not the number of color samples. However, since the number of color samples did not increase, fragment shaders are still run for each pixel only once. As a result, MSAA will not affect the following kinds of aliasing in any way. Aliasing within nearest neighbor filtered textures, pixel art, aliasing caused by custom 2D shaders, specular aliasing when using light 2D, aliasing in front rendering. MSA can be enabled in the project settings by changing the value of the rendering anti-aliasing quality MSA 2D setting. It's important to change the value of the MSA 2D settings and not MSA 3D, as these are entirely separate settings. Comparison between no anti-aliasing left and various MSA levels right. The top left corner contains a line 2D node. The top right corner contains 2 texture progress bar nodes. The bottom contains 8 pixel art sprites, with 4 of them touching the edges, green background, and 4 of them not touching the edges, Godot logo. Alright. Oh. We're still in rendering. Custom drawing in 2D, introduction. Godot has nodes to draw sprites, polygons, particles, text, and many other common game development needs. However, if you need something specific not covered with the standard nodes, you can make any 2D node, for example, control or node 2D, based on screen using custom commands. Custom drawing in a 2D node is really useful. Here are some use cases. Drawing shapes or logic that existing nodes can't do, such as an image that with trails or special animated polygon. Drawing a large number of simple particles, such as a grid or board for a 2D game, custom drawing avoids the overhead of using a large number of nodes, possibly lowering memory usage and improving performance. Making a custom UI control, there are plenty of controls available, but when you have unusual needs, you will likely need a custom control. Drawing. Add a script to add any canvas item derived node like control or node 2D, then override the draw function. Draw commands are described in the canvas item class reference. There are plenty of them. We will see some of them in the examples below. Updating. The draw function is only called once, and then the draw commands are cached and remembered, so further calls are unnecessary. If redrawing is required because a variable or something else changed, call canvas item Q redraw. In that same node, and a new draw call will happen. Here's a little more complex example where we have a texture variable that can be modified at any time, and using a setter, it forces a redraw of the texture when modified. To see it in action, you can set the texture to be the Godot icon on the editor by dragging and dropping the default icon.svg from the File System tab to the Texture property on the Inspector tab. When changing the texture property value from the previous script is while the previous script is running, the texture will also change automatically. In some cases, we may need to redraw every frame. For this, call QRedraw from the process method like this. Coordinates and line width alignment. The drawing API uses the canvas items coordinate system, not necessarily pixel coordinates, from means draw. Uses the coordinate space created after applying the canvas items transform. Additionally, you can apply a custom transform on top of it by using draw set transform or draw set transform matrix. When using draw line, you should consider the width of the line when using a width that is an odd size. The position of the start and end points should be shifted by 0.5 to keep the line centered, as shown below. The sample applies to the draw rect method with the filled false. Anti-aliasing redraw. Godot offers method parameters draw line to enable anti-aliasing, but not all custom drawing methods offer this anti-aliasing parameter. For custom drawing methods that don't provide an anti-alias parameter, you can enable 2D MSAA instead, which affects rendering in the entire viewport. This provides high quality anti-aliasing, but a higher performance cost, and only on specific elements. See 2D anti-aliasing for more information. Here's a comparison of a line of minimal width with -1, drawing with anti-aliased equals false, anti-aliased equals true, and anti-aliased equals false, with 2D MSA 2x, 4x, and 8x enabled. No AA, MSAA 2, MSAA 4, MSAA 8. Tools. Drawing your own nodes might also be desired while running them in the editor. This can be used as a preview or visualization of some feature or behavior. To do this, you can use the tool annotation on both GDScript and C#. See the example below and running code in the editor for more information. Example 1, drawing a custom shape. We will now use the custom drawing functionality of the Godot engine to draw something that Godot doesn't provide functions for. We will recreate the Godot logo, but with code, only using drawing functions. You will have a code function to perform this and draw it yourself. Note, the following instructions use a fixed set of coordinates that could be too small for high-resolution screens, larger than 1080p. If that is your case, and the drawing is too small, consider increasing your window scale in the project setting, display window stretch scale. To adjust the project to a high resolution, a 2 or 4 scale tends to work well. Drawing a custom polygon shape. While there is a dedicated node to draw custom polygons, Polygon 2D, we will use, in this case, exclusively lower-level drawing functions to combine them on the same node and be able to create more complex shapes later on. First, we will define a set of points, or x and y coordinates, that will form the base of our shape. This format while compact is not the one that Godot understands to draw a polygon. In a different scenario, we could have to load these coordinates from a file or calculate the positions while the application is running. So some transformation may be needed. To transform these coordinates into the right format, we will create a new method, floatArray to vector2array. Then we will override the ready function, which Godot will call only once at the start of the execution, to load those coordinates into a variable. To finally draw our first shape, we will use the method drawPolygon and pass these points as an array of vector2 coordinates and its color like this. When running it, you should see something like this. Note that the lower part of the logo looks segmented. This is because a low amount of points were used to define that part. To simulate a smooth curve, we could add more points to our array, or maybe use a mathematical function to interpolate a curve and create a smooth shape from code. See example 2. Polygons will always connect its last defined point to its first one in order to have a closed shape. Drawing connected lines. Drawing a sequence of connected lines that don't close down to form a polygon is very similar to the previous method. We will use a connected set of lines to draw Godot's logo mouth. First, we will define the first list of coordinates that form the mouth shape like this. We will load these coordinates into a variable and define an additional variable with the configurable line thickness. And finally, we'll use the method drawPipeline to actually draw the line like this. You should get the following output. Unlike drawPolygon, polylines can only have a single unique color for all of its points. The second argument, this method has two additional arguments: the width of the line, which is as small as possible by default, and enabling or disabling the anti-aliasing. It is disabled by default. In order of the _draw calls is important. Like with the node positions on the tree hierarchy, the different shapes will be drawn from top to bottom, resulting in the latest shapes hiding earlier ones if they overlap. In this case, we want the mouth drawn over the head, so we put it afterwards. Notice how we can define colors in different ways, either with a hexadecimal code or a predefined color name. Check the class color for other constants and other ways to define color. Drawing circles. To create the eyes, we're going to add 4 additional calls to draw the eye shapes in different sizes, colors, and positions. To draw a circle, you position it based on its center using the drawCircle method. The first parameter is a vector2 with the coordinates of its center. The second is its radius, and the third is its color. When executing it, you should have something like this. For partial unfilled arcs, portions of a circle shape between certain arbitrary angles, you can use the method drawArc. Drawing lines. To draw the final shape, the nose, we will use a line to approximate it. DrawLine can be used to draw a single segment by providing its start and end coordinates as arguments like this. You should be able to see the following shape on screen. Note that if multiple uncounted lines are going to be drawn at the same time, you may get additional performance by drawing all of them in a single column using the drawMultiple method. Drawing text. While using the label node is the most common way to add text to your application, the low-level draw function includes functionality to add text to your custom node drawing. We will use it to add the name Godot under the robot head. We will use the drawString method to do it like this. Here we first load into the default font variable the configured default theme font. A custom one can be set instead. And then we pass the following parameters: font, position, text, horizontal alignment, width, and font size. You should see the following on your screen. Additional parameters as well as other methods related to the text and characters can be found on the canvas item class reference. Show the drawing while editing. While the code so far is able to draw the logo on a running window, it will not show up on the 2D view on the editor. In certain cases, you would also like to show your custom 2D node or control on the editor to position and scale it appropriately, like most other nodes do. To show the logo directly in the editor without running it, you can use the @tool annotation to request the custom drawing of the node to also appear while editing, like this. You will need to save your screen, rebuild your project for C# only, and reload the current scene manually at the menu option. Scene, reload, save scene. To refresh the current node in the 2D view, the first time you add or remove the @tool animation. If we want to make the custom shape change at runtime, we could modify the method's called or its arguments at execution time, or apply a transform. For example, if we want the custom shape we just designed to rotate, we could add the following variable and node to the ready and process methods. The problem with the above code is that because we have created the points approximately on a rectangle starting from the upper left corner to 0, 0, or left corner, the 0, 0 coordinate, extending to the right and down, we see that the rotation is done using the top left corner as pivot. A position transform change on the node won't help us here, as the rotation transform is applied first. While we could rewrite all of the points coordinates to be centered around 0, 0, including negative coordinates, that would be a lot of work. One possible way to work around this is to use the lower level draw set transform method to fix this issue, translating all points in the canvas item's own space and then moving it back to the original place, with a regular node transform either in the editor or in code like this. This is the result rotating around a pivot now on 60, 60. If what we wanted to animate was a property inside the draw call, we must consider calling the queue redraw to force a refresh, as otherwise it would not be updated on screen. For example, this is how we can make the robot appear to open and close its mouth by changing the width of its mouth line follow a sinusoidal sine curve. It looks somewhat like this when we run. Please note that the mouth width is a user-defined property like any other, and it or any other used as a drawing argument can be animated using more standard and high-level methods such as a tween or an animation player node. The only difference is that a queue redraw call is needed to apply those changes so they can get shown on screen. Example 2, drawing a dynamic line. The previous example was useful to learn how to draw and modify nodes with custom shapes and animations. This could have some advantages, such as using exact coordinates and vectors for drawing rather than bitmaps, which means they will scale well when transformed on screen. In some cases, similar results could be achieved composing higher level functionality with nodes such as sprites or animated sprites, loading SVG resources, which are also images defined with vectors, and the animation player node. In other cases, that will not be possible because we will not know what the resulting graphical representation will be before running the code. Here we will see how to draw a dynamic line whose coordinates are not known beforehand and are affected by the user's input. Let me see here. Okay. That was really just nothing. And by nothing, assisting Ethan with a bishop order. Or not bishop order, getting stuff from Walmart. Bishop order was Saturday. Drawing a straight line between 2 points. Let's assume we want to draw a straight line between 2 points. The first one will be fixed on the upper left corner, 0, 0, and the second will be defined by the cursor position on screen. We could draw a dynamic line between those 2 points like this. In this example, we obtained the position of the mouse in the default viewport every frame with the method getMousePosition. If the mouse has changed since the last draw request, a small optimization to avoid redrawing on every frame. We will schedule a redraw. Our draw method only has one line, requesting the drawing of a green line with the width 10 pixels between the top left corner and that obtained position. The width, color, and position of the starting point can be configured with the corresponding properties. It should look something like this when run. Drawing an arc between 2 points. The above example works, but we may want to join 2 points with a different shape or function other than a straight line. Let's try now creating an arc, a portion of a circumference between both points. Exporting the line starting point segments with color and anti-aliasing will allow us to modify those properties very easily directly from the editor inspector panel. To draw the arc, we can use the method drawArc. There are many arcs that pass through 2D points, so we will choose for this example the semicircle that has its center in the middle point between two initial points. Calculating this arc will be more complex than in the case of the line. The center of the semicircle will be the middle point between both points. The radius will be half the distance between both points. The start and end angles will be the angles of the vector from point 1 to point 2 and vice versa. Note we had to normalize the end angle in positive values because if end angle is less than start angle, the arc will be drawn counterclockwise, which we don't want in case the arc would be upside down. The result should be something like this, with the arc going down in between the points. Feel free to play with the parameters in the inspector to obtain different results. Change the color, the width, the anti-aliasing, and increase the number of segments to increase the curve smoothness at the cost of extra performance. What? Nothing too important. 2D parallax. Introduction. Parallax is an effect used to simulate depth by having textures move at different speeds relative to the camera. Godot provides the Parallax 2D node to achieve this effect. It can still be easy to get tripped up though, so this page provides in-depth descriptions of some properties to how to fix some common mistakes. Note, this page covers how to use Parallax 2D, which is recommended to use the Parallax layer and Parallax background nodes. Getting started. The Parallax node supports adding nodes that render things as children, so you can use one or many nodes to make up each layer. To begin, place each node or nodes you want to have scroll independently as a child of their own Parallax node. Make sure that the top left of the textures used are at the 0,0 crossing, like in the image below. See the section on positioning for why this is important. The scene above uses one prepared texture for the higher clouds in a Sprite 2D, but you could just as easily use multiple nodes placed out to compose the layer. Scroll scale. The backbone of the parallax effect is the scroll scale property. It works as a scroll speed multiplier, allowing layers to move at a different speed than the camera for each axis set. A value of 1 makes a parallax node scroll from the same speed as the camera. If you want your image to look further away when scrolling, use a value lower than 1 when bringing it to a complete stop. If you want something to appear closer to the camera, use a value higher than 1, making it scroll faster. The scene above is comprised of 5 layers. Some good scroll scale values might be forest hills, lower clouds, higher clouds, sky. The video below displays how these values affect scrolling while in-game. Infinite repeat. Parallax 2D provides a bonus effect that gives textures the illusion of repeating infinitely. Repeat size tells the node to snap its position forward or back when the camera scrolls by the set value. This effect is achieved by adding a single repeat to all the child canvas items offset by the value, while the camera scrolls between the image and its repeat. It invisibly snaps back, giving the appearance of a looping image. Being a delicate effect, it's easy for unfamiliar users to make mistakes with their setup. Let's go over how and why of a few common problems users encounter. Poor sizing. The infinite repeat effect is easiest to work with when you have an image designed to repeat seamlessly, and is the same size or larger than your viewport before setting the repeat size. If you aren't able to obtain assets that are designed for this task, there are some other things you can do to better prepare your image in regards to size. Here's an example of a texture that is too small for its viewport. We can see that the viewport size is 500 by 300, but the texture is 288 by 208. If we set the repeat size to the size of our image, the infinite repeat effect couldn't scroll properly because the original size doesn't cover the viewport. If we set the repeat size to the size of the viewport, we have a large gap. What can we do? make the viewport smaller. The simplest way is to make the viewport the same size or smaller than your textures. In project settings display windows. In project settings display window, change the viewport width and viewport height setting to match your background. Scale the parallax 2D. If you're not aiming for pixel perfect style or don't mind a little blurriness, you may opt to scale the textures larger to fit your screen. Set the scale of the parallax 2D and all children textures scale with it. Set the scale nodes. Similar to scaling the parallax 2D, you can scale your sprite 2D nodes to be large enough to cover the screen. Keep in mind that some settings like parallax 2D repeat size and sprite 2D region rect do not take scaling into account, so it's necessary to adjust these values based on the scale. Repeat the textures. You can also start off on the right foot by preparing the child nodes earlier in the process. If you have a sprite 2D you'd like to repeat but is too small, you can do the following to repeat it. Set texture repeat to canvas item, texture repeat enabled, set region enabled to true, set the region rect to a multiple of the size of your texture large enough to cover the viewport. Below you can see that repeating the image twice makes it large enough to cover the screen. Poor positioning. It's common to see users mistakenly set all of their textures to be centered at 0, 0. This creates a problem with the infinite repeat effect and should be avoided. The infinite repeat canvas starts at 0, 0 and expands down and to the right of the size of the repeat size value. If the textures are centered on the 0, 0 crossing, the infinite repeat canvas is only partially covered, so it only partly repeats. Would increasing repeat times fix this? Increasing repeat times technically would work in some scenarios, but is a brute force solution and not the problem it is designed to solve. We'll go over this in a bit. A better fix is to understand how the repeat effect works and to set up the parallax textures appropriately to begin with. First, check to see if any textures are spilling over into the negative parts of the canvas. Make sure the textures used in the parallax nodes fit the same infinite repeat canvas starting at 0, 0. That way, if parallax 2D repeat size is set correctly, it should look something like this, with one single loop of the image the same size or larger than the viewport. If you think of how the image scrolls across the screen, it starts by displaying what's inside the red rectangle, determined by repeat size. And when it reaches what's inside the yellow rectangle, it zips the image forward to give the illusion of scrolling forever. If you have the image positioned away from the infinite repeat canvas, when the camera reaches the yellow rectangle, half of the image is cut off before it jumps forward, like in the image below. Scroll offset. If your parallax textures are already working correctly, but you prefer to start at a different point, Parallax 2D comes with a scroll offset property used to offset where the infinite repeat canvas starts. As an example, if your image is 288 by 208, set the scroll offset to -144, 0 or 144, 0. Allows it to begin halfway across the image. Repeat times. Ideally, following this guide, your parallax textures are large enough to cover the screen when, even when zoomed out. Until now, you have had a perfectly fitting 288 by 208 texture inside of a 288/208 viewport. However, problems occur when we zoom out by setting camera 2D zoom to 0.5 to 0.5. Even though everything is correctly set up for the viewport at the default zoom level, zooming out makes it smaller than the viewport, breaking the infinite repeat effect. This is where repeat times can help out setting a value of 3. One extra repeat behind and in front, it is now large enough to accommodate the infinite repeat effect. If these textures were meant to repeat vertically, we should have specified a Y value for the repeat size. The repeat times would automatically add a repeat above and below as well. This is only a horizontal parallax, so it leaves an empty block above and below the image. How do we solve this? We need to get creative. In this example, we stretch the sky higher and grass bright lower. The textures now support the normal zoom level and zooming out to half size. Split screen. Most tutorials for making a split screen game in Godot Engine by writing a small script to assign the viewport world 2D of the first sub-viewport in the second, so they have a shared display. Questions often pop up about how to share a parallax effect between both screens. The parallax effect fakes a perspective by moving the positions of different textures in relations to the camera. This is understandably problematic if you have multiple cameras, but your textures can't be in two places at once. This is still achievable by cloning the parallax nodes into the second, or third, or fourth sub-viewport here. In the second sub-viewport, or third or fourth. Here's how a setup looks for a two-player game. Of course, now both backgrounds show in both sub-viewports. What we want for each parallax to only show their corresponding viewport. We can achieve this by doing the following. Leave all parallax nodes at their default visible layer of 1. Set the first sub-viewport's canvas color mask to only layers 1 and 2. Do the same for the second sub-viewport, but use layers 1 and 3. Give your parallax nodes in the first sub-viewport a common parent and set its visibility layer to 2. Do the same for the second sub-viewport's parallax nodes, but use a layer of 3. How does this work? If a canvas item has a visibility layer that doesn't match the sub-viewport's canvas color mask, it will hide all children. If they do, we use this to our advantage. Let the sub-viewports cut off rendering of parallax nodes whose parent doesn't have a supportive visibility layer. Previewing in the editor. Prior to view 4.3, the recommendation was to place every layer in their own parallax background, enable the follow viewport enabled property, and scale the individual layer. This method has always been tricky to get right, but is still achievable by using a canvas layer instead of a parallax background. Another recommendation is Kobewee's Parallax 2D Preview add-on. It provides a few different preview modes and is very handy. 2D Movement Overview. Introduction. Every beginner has been there. How do I move my character? Depending on the style of games, depending on the style of game you're making, you may have special requirements, but in general, the movement in most 2D games is based on a small number of designs. We'll use Character Body 2D for these examples, but the principles will apply to other node types. Area 2D, Rigid Body 2D as well. Setup. Each example below uses the same scene setup. Start with a Character Body 2D with 2 children. Sprite 2D and Collision Shape 2D. You can use the Godot icon PNG for the Sprite 2D's texture or use any other 2D image you have. Open project settings and select the Input Map tab and the following input actions. See Input Event for details. 8-way movement. In this scenario, you want the user to press the 4 directional keys, up, left, down, right, or WASD, and move in the selected direction. The name 8-way movement comes from the fact that the player can move diagonally by pressing 2 keys at the same time. Add a script to the character body and the following code. In the getInput function, we use input getVector to check for the 4 key events and some return a direction vector. We can then set our velocity by multiplying its direction vector, which has a length of 1, by our desired speed. Tip: if you've never used vector math before or need a refresher, you can see an explanation of vector usage in Godot at Vector Math. Note: if the code above does nothing, then when you press the keys, double click to check that you've set up input actions correctly as described in the setup part of this tutorial. Rotation and movement. I think for the most part we've gone through this before. Using tile sets. Introduction. A tile map is a grid of tiles used to create a game's layout. There are several benefits using tile map layer nodes to design your levels. First, they let you draw a layout by painting tiles onto a grid, which is much faster than placing individual Sprite 2D nodes one by one. Second, they allow for larger levels because they are optimized for drawing large numbers of tiles. Finally, they allow you to add greater functionality to your tiles with collision, occlusion, and navigation shapes. To use tile map layered nodes, you will need to create a tile set first. A tile set is a collection of tiles that can be placed in a tile map layer node. After creating a tile set, you will be able to place them using the tile map editor. To follow this guide, you will need an image containing your tiles where every tile has the same size. Large objects can be split into several tiles. This image is called a tile sheet. Tiles do not have to be square. They can be rectangular, hexagonal, or isometric, pseudo 3D perspective. Creating a new tile set. Using a tile sheet. This demonstration will use the following tiles taken from Kenny's Abstract Platformer pack. We'll use this particular tile sheet from the set. A tile sheet with 64 by 64 tiles. Credit Kenny. Create a new tile map layer node, then select it and create a new tile set resource in the inspector. Creating a new tileset resource within the tile map node. After creating the tileset resource, click the value to unfold it in the inspector. The default tile shape is square, but you can also choose isometric, half offset square, or hexagon, depending on the shape of your tile images. If using a tile shape or other than square, you may also need to adjust the tile layout and tile offset axis properties. Lastly, enabling the rendering UV clipping property may be useful if you wish tiles to be clipped by their tile coordinates. This ensures tiles cannot draw outside their allocated area on the tile sheet. Set the size to 64 by 64 in the inspector to match the example tile sheet. Setting the tile size to 64 by 64 to match the example tile sheet. If relying on automatic tiles creation, like we're about to do here, you must set the tile size before creating the atlas. The atlas will determine which tiles from the tile sheet can be added to the tile map layer. Tile map layer node, as not every part of the image may be a valid tile. Open the tile set panel at the top of the editor, then click and drag the tile sheet image onto the panel. You will be asked whether to create tiles automatically. The answer, yes. Automatically creating tiles based on tile sheet image content. This will automatically create tiles according to the tile size you specified earlier in the tile set resource. This greatly speeds up initial tile setup. Note, when using automatic tile generation based on input contents, parts of the tile sheet that are fully transparent will not have tiles generated. If there are tiles from the tile sheet you do not wish to be present in Atlas, choose the eraser tool at the top of the tile set preview, then click the tiles you wish to remove. Using the eraser tool to remove unwanted tiles from the tileset atlas, you can also right-click the tile and choose delete as an alternative to the eraser tool. Tip: like in the 2D and tile map editors, you can pan across the tileset panel using the middle or right mouse buttons and zoom using the mouse wheel or buttons in the top left corner. If you wish to source tiles from several tile sheet images for a single tile set, create additional atlases and assign textures to each of them before continuing. It is also possible to use one image per tile this way, although using tile sheets is recommended for better usability. You can adjust properties for the atlas in the middle column. Adjust tile set atlas properties in dedicated inspector part of the tileset panel. The following properties can be adjusted on the atlas. ID. The following properties can be adjusted on the atlas. ID, the identifier unique within the tileset used for sorting. Name, the human readable name for the atlas. Use a descriptive name here for the organizational purposes such as terrain, decoration, etc. Margins. See margins on the image's edges that should be selectable as tiles in pixels. Increasing this can be useful if you download a tile sheet image that has margins on the edges. Example for attribution. Separation. The separation between each tile on the atlas is in pixels. What? No, pause that. I purely just want to, shuffle through this. I don't want anything else. 2 hours, 45 minutes. Why did it do that? Okay, weird. Oh well. This is a previous stream, I think. Yeah, no, it's a previous stream. What speed is it? Okay. Note that changing texture, margin, separation, and region size may cause tiles to be lost, as some of them would be located outside the atlas image's coordinates. To regenerate tiles automatically from the tile sheet, use the 3 vertical dots menu button at the top of the tileset editor, and choose Create Tiles in non-transparent texture regions. Recreating tiles automatically after changing atlas properties. Using a collection of scenes. You can also place actual scenes as tiles. This allows you to use any collection of nodes as a tile. For example, you could use scene tiles to place gameplay elements such as shops for the player may be able to interact with. You could also use the scene tiles to place audio stream player 2Ds for ambient sounds, particle effects, and more. Warning, scene tiles come with a greater performance overhead compared to atlases, as every scene is instanced individually for every place tile. It's recommended to only use scene tiles when necessary. To draw sprites in a tile without any kind of advanced manipulation, use atlases instead. For this example, we will create a scene containing a CPU particles 2D root node. Save this scene to a scene file separate from the scene obtaining the tile map layer. Then switch to the scene containing the tile map layer node. Open the tileset editor and create a new scene scenes collection in the left column. After creating a scenes collection, you can enter a descriptive name for the scenes collection in the middle column if you wish. Select this scenes collection, then create a new scene slot. Select the scene slot in the right column, then use quick load or load to load the scene file containing the particles. You now have a scene tile in your tileset. Once you switch to the tile map editor, you'll be able to select from the scenes collection and paint it like any other tile. Merging several atlases into a single atlas. Using multiple atlases within a single tileset resource can sometimes be useful, but it can also be cumbersome in certain situations, especially if you're using one image per tile. Godot allows you to merge several atlases into a single atlas for easier organization. To do so, you must have more than one atlas created in the tileset resource. Use the 3 vertical dots menu button located in the bottom of the list of atlases. Then choose Open Atlas Merging Tool. This will open a dialog in which you can select several atlases by holding Shift or Control, then clicking on multiple elements. Choose Merge to merge the selected atlases into a single atlas image, which translates to a single atlas within the tileset. The unmerged atlases will be removed within the tileset, but the original tilesheet images will be kept on the file system. If you don't want the unmerged atlases to be removed from the tileset resource, choose Merge, keep original atlases instead. Tip: tileset features a system of tile proxies. Tile proxies are a mapping table that allows notifying the tile map using a given tileset that a given set of tile identifiers should be replaced by one another. Tile proxies are automatically set up when merging different atlases, but they can also be set manually thanks to the Manage Tile Proxies dialog you can access using the 3 vertical dots menu mentioned above. Manually creating tile proxies may be useful when you changed an atlas ID, or want to replace all tiles from an atlas by the ones from another atlas. Note that when editing a tile map, or want to replace all tiles from an atlas by the ones from another atlas, note that when editing a tile map, you can replace all cells by their corresponding mapped values. I think I did weird shit. Adding collision, navigation, and occlusion to the tile set. You've now successfully created a basic tile set. We could start using it in the tile map layer node now, but it currently lacks any form of collision detection. This means the player and other objects could walk straight through the floor or walls. If you use 2D navigation, you'll also need to define navigation polygons for tiles to generate a navigation mesh with a mesh that agents can use for pathfinding. Lastly, if you use lights and shadows or GPU particles 2D, you may also want your tile set to be able to cast shadows and collide with particles. This requires defining occluder polygons for solid tiles on the tile set. To be able to define collision, navigation, and occlusion shapes for each tile, you will need to create a physics navigation or occlusion layer for the tile set resource first. To do so, select the tile map layer node, click the tile set property value in the inspector to edit it, then unfold physics layers and choose add element. If you also need navigation support, now's a good time to create a navigation layer. If you need support for a light polygon occluders, now is a good time to create an occlusion layer. Note, future steps in this tutorial are tailored to creating collision polygons, but the procedure for navigation and occlusion is very similar. The respective polygon editors behave in the same way, so these steps are not repeated for brevity. The only caveat is that the tile occlusion polygon property is part of a rendering subsection in the Atlas Inspector. Make sure to unfold this section so you can edit the polygon. After creating the physics layer, you have access to the physics layer section in the tileset Atlas Inspector. You can quickly create a rectangle collision shape by pressing F while the tileset editor is focused. If the keyboard shortcut doesn't work, try clicking in the empty area around the polygon editor to focus it. In this tile collision editor, you can have access to all the 2D polygon editing tools. Use the toolbar above the polygon to toggle between creating a new polygon, editing an existing polygon, and removing points on the polygon. The 3 vertical dots menu button offers additional options such as rotating and flipping the polygon. Create new points by clicking and dragging a line between 2 points. Remove a point by right-clicking it, or use the remove tool described above and left-clicking. Pan in the editor by middle-clicking or right-clicking. Right-click panning can only be used in areas where there is no point nearby. You can use the default rectangle to shape to quickly create a triangle shape collision shape by removing one of your points. You can also use a rectangle as a base for complex shapes by adding more points. Tip: if you have a large tile set, specify the collision for each tile individually. Could take a lot of time. This is especially true as tile maps tend to have many tiles with common collision patterns, such as solid blocks or 45-degree slopes. To apply a similar collision shape to several tiles quickly, use functionality to assign properties to multiple tiles at once. Assigning custom metadata to the tile set's tiles. You can assign custom data on a per tile basis using custom data layers. This can be useful to store information specific to your game, such as the damage that a tile should deal when a player touches it, or whether a tile can be destroyed using a weapon. The data is associated with the tile in the tile set. All instances of the place tile will use the same custom data. If you need to create a variant of a tile that has different custom data, this can be done by creating an alternative tile and changing the custom data for the alternative tile only. Creating a custom data layer in the tileset resource inspector within the don't need to read that. You can reorder custom data without breaking an existing metadata. The tileset editor will update automatically after recording custom data properties. With the custom data layers example shown above, we're assigning a tile to have the damage per second metadata set to 25 and the destructible metadata to false. Tile property painting can also be used for custom data. Grading terrain sets, auto-tiling. This functionality was implemented in a different form as auto-tiling in Godot 3.x. Terrains are essentially a more powerful replacement of auto-tiles. Unlike auto-tiles, terrains can support transitions from one terrain to another. That's a tile may define several terrains at once. Unlike before, where auto-tiles were a specific kind of tiles, terrains are only a set of properties assigned to Atlas tiles. These properties are then used by a dedicated tile map painting mode that selects tiles featuring terrain data in a smart way. This means any terrain can be either painted as terrain or as a single tile like any other. A polished tile set generally features variations that you should use on corners or edges of platforms, floors, etc. While these can be placed manually, these quickly become tedious. Handling this situation with procedurally generated levels can also be difficult and require a lot of code. Godot offers terrains to perform this kind of tile connection automatically. This allows you to have the correct tile variants automatically used. Terrains are grouped into terrain sets. Each terrain set is assigned a mode from match corners and sides, match corners and match sides. They define how terrains are matched to each other in a terrain set. Note, the above modes correspond to the previous bitmask modes, auto tiles used in Godot 3.x, 2x2, 3x3, or 3x3 minimal. This is also similar to the tiled editor features. Select the tile map layer node, go to the inspector, and create a new terrain set within the tile set resource. After creating a terrain set, you must create one or more terrains within the terrain set. In the tile set editor, switch to select mode and click a tile. In the middle column, unfold the terrain section, then assign a terrain set ID and terrain ID for the tile. -1 means no terrain set or no terrain, which means you must set the terrain set to 0 or greater before you can set terrain to 0 or greater. Terrain set IDs and terrain IDs are independent from each other. They also start from 0, not 1. After doing so, you can now create the terrain peering bits section, which becomes visible in the middle column. The peering bits determine which tile will be placed during, depending on neighboring tiles. -1 is a special value which refers to empty space. For example, if a tile has all its bits set to 0 or greater, it will only appear if all 8 neighboring tiles are using a tile with the same terrain ID. If a tile has its bits set to 0 or greater, but the top left and top right bits are set to -1, it only appears if there is empty space on top of it, including diagonally. An example configuration for a full tile set sheet may look as follows. Example full tile sheet for a side-scrolling game. Assigning properties to multiple tiles at once. There are two ways to assign properties to multiple tiles at once, depending on your use cases. One method may be faster than the other. Using multiple tile selection. If you wish to configure various properties on several tiles at once, choose the select mode at the top of the tile set editor. After doing this, you can select multiple tiles on the right column by holding Shift, then clicking on tiles. You can also perform rectangle selection by holding down the left mouse button, then dragging the mouse. Lastly, you can deselect the tiles that were already selected without affecting the rest of the selection by holding Shift, then clicking on the selected tile. You can then assign properties using the inspector in the middle column of the tileset editor. Only properties that you can change here will be applied to all selected tiles, like in the editor's inspector. Properties that differ on selected tiles will remain different until you edit them. With numerical and color properties, you will see a preview of the properties value on all tiles in the atlas after editing a property. Using the tile property painting. If you wish to apply a single property to several tiles at once, you can use the property painting mode for this purpose. Configure a property to be painted in the middle column and then click on tiles, or hold down the left mouse button in the right column to paint properties onto tiles. Tile property painting is especially useful with properties that are time-consuming to set manually, such as collision shapes. Creating alternative tiles. Sometimes you want to use a single tile image found only once within the atlas, but configured in different ways. For example, you may want to use the same tile image, but rotated, flipped, or modulated with a different color. This can be done using alternative tiles. Since Godot 4.2, you don't have to create alternative tiles or rotate or flip tiles anymore. You can rotate any tile while placing it in the tile map editor by using the rotate flip buttons in the tile map editor toolbar. To create an alternative tile, right click on a base tile in the atlas display by the tile set editor, then choose create an alternative tile. If currently in select mode, the alternative tile will already be selected for editing. If not currently in select mode, you can still create alternative tiles, but you will need to switch to select mode and select the alternative tile to edit it. If you don't see the alternative tile, pan over to the right of the atlas image, as alternative tiles always appear on the right side of the base tiles of a given atlas in the tileset editor. After selecting an alternative tile, you can change any properties using the middle column like you would on a base tile. However, the list of exposed properties is different compared to base tiles. Alternative ID. The unique numerical identifier for this alternative ID, alternative tile. Changing it will break existing tile maps, so be careful. This ID also controls the sorting in the list of alternative tiles displayed in the editor. Rendering flip H if true, the tile is horizontally flipped. Rendering flip V if true, the tile is vertically flipped. Rendering transpose. If true, the tile is rotated 90 degrees counterclockwise and then flipped vertically. In practice, this means that to rotate a tile by 90 degrees clockwise without flipping it, you should enable flip H and transpose. To rotate a tile by 100 degrees clockwise, enable flip H and flip V. To rotate a tile by 280 degrees clockwise, enable flip V and transpose. Rendering texture origin. The origin to use for drawing the tile. This can be used to visually offset the tile compared to the base tile. Rendering modulate. The color multiplier to use when rendering the tile. Rendering material. The material to use for this tile. This can be used to apply a different blend mode or custom shaders to a single tile. Z-index. The sorting order for this tile. Higher values will make the tile render in front of others on the same layer. Y-sort origin. The vertical offset to use for tile sorting based on Y coordinates in pixels. This allows using layers as if they were on different height for top-down games. Adjusting this can help alleviate issues with sorting certain tiles, only effective if Y-sort enabled is true. On the tile map layer node under canvas item ordering. You can create an additional alternative tile variant by clicking the large plus icon next to the alternative tile. This is equivalent to selecting the base tile and right-clicking it to choose create an alternative tile again. Note, when creating an alternative tile, none of the properties from the base tile are inherited. You must set properties again on an alternative tile if you wish to use those identical. If you wish those to be identical on the base tile and the alternative tile. Alright. I need to use the bathroom again. I don't know why I need to so much today. It's odd. Alright. Oh, was that too loud? I'm not sure. Ugh. Why is there a line on here? I don't know. Alright. Last section of 2D. Using tile maps. See, also the page assumes you have created or downloaded tileset already. If not, please read using tilesets first, as you will need the tileset to create a tile map. Introduction: a tile map is a grid of tiles used to create a game's layout. There are several benefits to using tile map layer nodes to design your levels. First, they make it possible to draw the layout by painting the tiles onto a grid, which is much faster than placing individual Sprite 2D nodes one by one. Secondly, they allow for much larger levels because they are optimized for drawing large numbers of tiles. Finally, you can add occlusion and navigation shapes to tiles, adding greater functionality to the tile map, specifying the tileset in the tile map layer. If you followed the previous page on using tilesets, you should have a tileset resource that is built into the tile map layer node. It is good for prototyping, but in a real-world project, you will generally have multiple levels reusing the same tileset. The recommended way to reuse the same tileset in several tile map layer nodes is to have the tileset to an external resource. To do so, click the drop-down next to the tileset resource and choose Save. Multiple tile map layers and settings. When working with tile maps, it's generally advised that you use multiple tile map layer nodes when appropriate. Using multiple layers can be advantageous. For example, this allows you to distinguish foreground tiles from background tiles for better organization. You can place one tile per layer at a given location, which allows you to overlap several tiles together if you have more than one layer. Each tile map layer node has several properties you can adjust. Enabled, if true, the layer is visible in the editor when running the project. Tileset, the tileset used by the tile map layer node. Rendering. Y sort origin, the vertical offset to use for Y sorting on each tile and pixels. Only effective if Y sort enabled under canvas item settings is true. Extra order reverses the order tiles are drawn on the x-axis. Requires that Y sort enabled under canvas item settings is set to true. Rendering quadrant size. A quadrant is a group of tiles drawn together on a single canvas for optimization purposes. This setting defines the length of a square's side in the map's coordinate system. The quadrant size does not apply to a Y-sorted tile map layer, since tiles are grouped by Y position in that case. Physics. Collision enables or disables collision. You use kinematic bodies. When true tile map layer collision shapes will be instantiated as kinematic bodies. Collision visibility mode. Whether or not the tile map layer's collision shapes are visible. If set to default, then it depends on the show collision debug settings. Navigation. Navigation enabled whether or not navigation regions are enabled. Navigation visible, whether or not tile map layers navigation meshes are visible. If set to default, then it depends on the show navigation debug settings. Tip: tile map built-in navigation has many practical limitations that result in inferior pathfinding, performance, and path following quality. After designing the tile map, consider baking it to a more optimized navigation mesh and disabling the tile map and navigation layer. Using the navigation region or the navigation server 2D, see using navigation meshes for additional information. Warning: 2D navigation meshes cannot be layered or stacked on top of each other like visuals or physics shapes. Attempting to stack navigation messages on the same navigation map will result in merge and logical errors that break the pathfinding. Reordering layers. You can reorder layers by drag and dropping their node in the Scene tab. You can also switch between which tile map layer node you're working on by using the buttons in the top right corner of the tile map editor. Note: you can create, rename, or reorder layers in the future without affecting existing tiles. Be careful though, as removing a layer will also remove all the tiles that were placed on the layer. Opening the tile map editor. Select the tile map layer node, then open the tile map panel at the bottom of the editor. Selecting the tiles to use for painting. First, if you've created additional layers above, you make sure you've selected the layer you wish to paint on. Tip: in the 2D editor, layers you aren't currently editing from the same tile map layer node will appear grayed out while the on the tile map editor. You can disable this behavior by clicking the icon next to the layer selection menu. Highlighted selected tile map layer tooltip. You can skip the above step if you haven't created additional layers, as the first layer is automatically selected when entering the tile map editor. Before you can place tiles in the 2D editor, you must select one or more tiles in the tile map panel located at the bottom of the editor. To do so, click a tile in the tile map panel or hold down the button to select multiple tiles. Tip: like in the 2D and tile set editors, you can pan around the tile map using the middle or right mouse buttons and zoom using the mouse wheel or buttons in the top left corner. You can also hold down Shift to append the current selection. When selecting more or one tile, multiple tiles will be placed every time you perform a painting operation. You can this can be used to paint structures composed of multiple tiles in a single click, such as large platforms or trees. The final selection does not have to be contiguous. If there is empty space between selected tiles, it will be left empty in the platform that will be painted in the 2D editor. If you've created alternative tiles in your tile set, you can select them for painting on the right of the base tiles. Lastly, if you've created a scene collection in the tile set, you can place scene tiles in the tile map. Painting modes and tools. Using the toolbar at the top of the tile map editor, you can choose between several painting modes and tools. These modes affect operation when clicking in the 2D editor, not the tile map panel itself. From the left to right, the painting modes and tools you can choose are Selection. Select the tiles by clicking a single tile or by holding down the left mouse button to select multiple with a rectangle in the 2D editor. Note that empty space cannot be selected. If you create a rectangle selection, only non-empty tiles will be selected. To append the current selection, hold Shift, then select a tile. To remove from the current selection, hold Control, then select a tile. The selection can then be used in any other painting mode to quickly create copies of an already placed pattern. You can remove the selected tiles from the tile map by pressing Delete. You can toggle this mode temporarily while in painting mode by holding Control, then performing a selection. Tip: you can copy and paste tiles that were already placed by performing a selection by pressing Ctrl-C, then pressing Ctrl-V. The selection can be pasted after left-clicking. You can press Ctrl-V another time to perform more copies this way. Right-click or press Escape to cancel pasting. Paint. The standard paint mode allows you to place tiles by clicking or holding down the left mouse button. If you right-click the currently selected tile by erasing from the tile map, in other words, it will be replaced by empty space. If you have selected multiple tiles in the tile map or using the selection tool, they will be placed every time you click or drag the mouse while holding down the left mouse button. Tip: while in painting mode, you can draw a line by holding Shift before holding down the left mouse button when dragging the mouse to the line's endpoint. This is identical to using the line tool described below. You can also draw a rectangle by holding Control and Shift before holding down the left mouse button, then dragging the mouse to the rectangle's endpoint. This is identical to using the rectangle tool described below. Lastly, you can pick existing tiles in the 2D editor by holding Control, then clicking on a tile, or holding and dragging the mouse. This will switch the currently painted tiles to the tiles you've just clicked. This is identical to using the picker tool described below. Line. After selecting the line paint mode, you can draw in a line that is always one tile thick, no matter its orientation. If you right-click while in line paint mode, you will erase in a line. If you have selected multiple tiles in the map tile or using the selection tool, you can place them in a repeating pattern across the line. You can toggle this mode temporarily while in paint or eraser mode by holding Shift, then drawing. Rectangle. After selecting rectangle paint mode, you can draw in an axis-aligned rectangle. If you right-click while in rectangle paint mode, you will erase in an axis-aligned rectangle. If you have selected multiple tiles in the tile map or using the selection tool, you can place them in a repeating pattern in the within the rectangle. You can toggle this mode temporarily while in the paint or erase mode by holding Control and Shift, then drawing. bucket fill. After selecting bucket fill mode, you can choose whether painting should be limited to contiguous areas only by toggling the contiguous checkbox that appears on the right of the toolbar. If you enable contiguous by default, only matching tiles that touch the current selection will be replaced. This contiguous check is performed horizontally and vertically, but not diagonally. If you disable contiguous, all tiles with the same ID in the entire tile map will be replaced by the currently selected tile. If selecting an empty tile with contiguous unchecked, all tiles in the rectangle that encompass the tile map's effective area will be replaced instead. If you right-click while in bucket fill mode, you will replace matching tiles with empty tiles. If you have selected multiple tiles in the tile map or using the selection tool, you can place them in a repeating pattern within the filled area. Picker. After selecting picker mode, you can pick existing tiles in the 2D editor by holding Control, then clicking on a tile. This will switch the currently painted tile to the tile you've just clicked. You can also pick multiple tiles at once by holding down the left mouse button and forming a rectangle selection. Only non-empty tiles can be picked. You can toggle this mode temporarily while in paint mode by holding Control, then clicking or dragging the mouse. Eraser. This mode is combined with any other painting mode, paint line, rectangle, paint bucket fill. Then erasing mode is enabled. The tiles will be replaced by empty tiles instead of drawing new lines when left-clicking. You can toggle this mode temporarily while in any other mode by right-clicking instead of left-clicking. Painting randomly using scattering. While painting, you can optionally enable randomization when enabled. A random tile can be chosen between all the currently selected tiles when painting. This is supported with the paint line, rectangle, and bucket fill tools. For effective paint randomization, you must select multiple tiles in the tile map editor for use scattering. Both approaches can be combined. If scattering is set to a value greater than 0, there's a chance that no tile will be placed when painting. This can be used to add occasional non-repeating detail to large areas, such as adding grass or crumbs on a large top-down tile map. Example when using paint mode. Example when using bucket fill mode. Note, eraser mode does not take randomization and scattering into account. All tiles within the selection are always removed. Saving and loading pre-map tile placements using patterns. Okay. While you can copy and paste tiles while in select mode, you may wish to save pre-made patterns of tiles to place together in a go. This can be done on a per tile map basis by choosing the Patterns tab of the tile map editor. To create a new pattern, switch to select mode. Perform a selection and press Ctrl+C. Click on empty space within the Patterns tab. A blue focus rectangle should appear around the empty space. Then press Ctrl+V. To use an existing pattern, click its image in the Patterns tab, switch to any painting mode, then left-click somewhere in the 2D editor. Like multi-tile selections, patterns will be repeated if used with the line, rectangle, or bucket fill painting modes. Note, despite being edited in the tile map editor, patterns are stored in the tilesets resource. This allows refusing patterns in different tile map layer nodes after loading a tileset resource saved to an external file. Handling tile connections automatically using terrains. To use terrains, the tile map layer node must feature at least one terrain set and a terrain within this terrain set. See creating terrain sets auto tiling if you have created a tile set for the tile set yet. There are 3 kinds of painting modes available for terrain connections. Connect, where tiles are connected to surrounding tiles on the same tile map layer. Path, where tiles are connected to tiles painting in the same stroke until the mouse button is released. Tile, specific overrides to resolve conflicts or handle situations not covered by the terrain system. The connect mode is easier to use, but path is more flexible as it allows for more artist control during painting. For instance, path can allow roads to be directly adjacent to each other without being connected to each other, while connect will force both roads to be connected. Lastly, you can select specific tiles from the terrain to resolve conflicts in certain situations. Any tile that has at least one of its bits set to a value set to the corresponding terrain ID will appear in the list of tiles to choose from. Handling missing tiles. If you remove tiles from the tile set that are referenced in a tile map, the tile map will display a placeholder to indicate that an invalid tile ID is placed. If you remove tiles in the tile set that are... Oh, shit. These placeholders are not visible in the running project, but the tile data is still persisted to disk. This allows you to safely close and reopen such scenes. Once you re-add a tile with the matching ID, the tiles will appear with the new tile's appearance. Note, missing the placeholders may not be visible until you select the tile map layer node and open the tile map editor. Animation, 2 animation nodes in Godot, and the animation editor. Okay. XR, virtual reality and augmented reality. User interface. Shaders, scripting, rendering, plugins, platform specific. Okay. Next thing we're on is animation though. But I want to take a bit of a break, because that's been just a lot of non-stop reading. So, let's see here. Unfortunate. 12. Crazy. And then here. Views, watch time, subscribers. Same day. Watch time in hours. 0.5 views, 15. Interesting. Alright. Curious. Just remove that. Don't worry about what I'm doing. Okay. Okay. Scene branches. Scripts. Utility. Oh. I can just delete that. Remove. Scene branches. But it's stretched out. It doesn't look the best. Got enemy 1, 2, and 3. Character 1, 2, and 3 with health bars here, and then we got fight, action, magic, item. Blah blah blah. Interesting. 2, 3, 4. Scripting, rendering, plugins. Oh. 2, 3, 4. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Seventeen, 18, 19, 20, 21, 22, 23, 24, 25, 26. 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 9, 40, 41, 42, 43, 44, 45, 46, 47, 48. Ooh. Okay, I'll be back. You guys have fun with the music. Ugh, needed that break. My
Shelby, come here.
no, come here, Chubby. Okay. Yeah, what the hell? That's way too loud. Okay, let's turn it down to 8. 6.5. How's that? Nope. 3.7? Yes, that should be fine. My brain was just melting from all of that reading. So, I needed a bit of a break from it. Just a bit. Alright. Let's see. I did say I might have a short stream today. This is kind of a nice place to stop. Kind of. Wait, just pull that back over and minimize it. So this. Enemies. I have... Let's see. Oh, never mind. I just have stretch mode to tile. Okay. So we have background 1, 2, 3, and 4. What the? Nothing I need to worry about right now. Don't worry about the character numbers. That's because I was having troubles with it. Progress bar. Value 100? Okay. And then for the background, scene branches. There's another thing. Oh, that's just the program for these, the scripts for these. And, oh, was it theme? No. Visibility. Oh, where was it? Where was it? Just go to the first one. In the back there. Order texture material. Visibility. Modulate. There's like somewhere in here there should be a way to change the color, localization, tooltip, focus, mouse input, accessibility, theme. This, okay, that's everything. Ah. Canvas item. The ordering. Modulate, self-modulate, show behind parent, top level, clip children, light mask, ordering, texture, material. scene. Shader parameter scrolling. And that's to allow it to move around like that, right? You have this. Changes the that. Uniform float speed. Canvas item. How the hell did I change? It'll translate interpolation process. Change the color of it without having to do anything. Without having to do much. Texture. Is it this? Resource. No. Keep size. Stretch mode, tile. Flip horizontally, flip vertically, layout. Transform. Size, position, rotation, scale. It's not layout. Localization, tooltip. Focus. Mouse. Input. Accessibility. Theme. Visibility. Is it this? Might be this. Let's change it all down. Then because if I have it just straight black, then you can't see it at all. Oh. That, and then the modulate here. Okay, here we go. Add it to that. Alright. And then if I wanted to change it to red, I would just change this value and change it to red. And I'd have to do it for all of these. It's invisibility. And change that up. Yeah, and then we have red here. It's not that overwhelming of a red, because it's mixed with other colors as well. So we can have red, but we can also have other values. Say that. Yellow. Yellow. And then just green. green. Oh, wait. No, it has to be 63. It has to be 63. For all of them. And then boom, we got green. And it would be 63, 255, 63, 255. And the final one, just tune this up, and 63. And boom, all of them are the proper shade of blue that they should be. And then this one goes to 255. And this one to 255. And all of them to 255. Yay! Looks great. And then the next color. And the last one. Huzzah. Oh, wait, not last one. There's still one more color to take a look at. Or, no, not one last. There's still two more colors to look at. White. And also... Oh, what was the number? 255 minus 63. No, it'd be minus 64, but 127 and 2 6 7 6 7 8 191. So 191 for all of these. So that's the center. And that should make it gray. Not 911, 191. And there we go. And then there's gray. So yeah, black, red, green, blue, cyan, yellow, magenta, white, gray. 9. 9 different colors for 9 different chapters. that yeah, or chapter sort of, chapter-ish, but let's change these all back to 63. Yeah, that's definitely darker. And boom, we're at black. And also, yeah, all of these are moving just at different rates. Front ones are moving faster than the back ones. Enemies. There's probably a way to make these, all go at the same time, but I don't want to worry about that. Right now anyway. See if I play it. Should. Yes. However, I want the camera to fit the screen. Spectre. Move, no. Maybe it's this. Let me check that real quick. It's nothing. View. Skeleton options, group selection, lock, snapping options. I don't think it's up here. Let's see. Display scaling, .4. Da da da. It might be in project settings. Why did it open over there? Application, general, window. Scale mode, fractional integer. Aspect, keep handheld. Orientation. Landscape, desync. Enabled. mouse cursor, buses, rendering, local, common fonts, theme, renderer. Okay, I know I wasn't gone. I know it was gone not too long ago, but I'll be back. Alright. And back. Alright. Mode windowed. Full screen. Okay, okay. Oh, that's weird. Why does it do that? Project settings, full screen, maximized. That is weird. Project settings. Minimized. Stop it. Project settings. Maximize full screen, exclusive full screen. Why is it doing that? Is it being so weird with the rendering? Because on here, it's not like that. Keep centered. Expand mode, keep size, keep centered. Keep size, keep centered. How did it boot? Booted like that. Windowed. Probably just full screen. Integer? Let's try it. No. Why? Off. Stretch mode. Disabled. Oh, whoa. Let's try keep. Viewport. Center of primary screen. Keep width. And it still does that. Full screen. Borderless, resizable, yes, yes. Borderless. No, I don't. Always on top. Transparent, extend title. No focus, sharp corners. Try canvas items. Okay, I guess I can't have that open. Okay, okay. However, that's not quite right. I need you over here. It's items and then viewport. And then it does that. Okay. Canvas items. Aspect. Expand. No. Nope. Okay, we'll just have it at canvas items then. We'll keep the aspect ratio. Scale mode, short fractional. Yeah, that should be good. For this. Okay. And that way, it actually works. No. Okay. Huh. No, menu. Hi. Welcome back.
No.
What you come back for?
No.
Or were you?
Shits and giggles for.
Ah.
Also, I'm not actually here. I'm just a figment of your imagination. You're imagining all of this.
Mm. Mm. Yeah. Yeah. Totally. What does this do? Menu. What?
Just the fact that I came back while Phoenix Wright's objection theme was playing over your playlist.
Oh. Yeah.
I just find that funny because, as we know,
No, we don't know.
I am Mr. Wright.
Hmm. Okay. And then let's grab.
Thanks. Wait, cat, stupid.
Probably another button. Oh, I need one of those. Another grid container. And then the button goes in here. Layout. Oh. And in. No, I just want. Okay. And we look at this transform. Let's see. How many columns can we have? Let's try 3. Oh. Uh, Layout. Would it be in grid container? That'd probably be in here. Layout. Vertical. Shrink. Shrink center. Expand. Let's set this back to 1. Shrink center, shrink end. Okay. Don't need fill. Center, shrink end. Do any of these change anything? I do not think so. So then how do I get the... Doesn't really matter on that.
Oh,
Oh. Turn all of those to flat. Action. Theme, accessibility, input, mouse, focus.
thanks.
Transform size, position, rotation, scale, offset, ratio. Editor, auto translate, physics interpolation process, material, texture, ordering, visibility, theme overrides, theme, accessibility, input, mouse, focus, localization, layout. Rotation, scale, pivot, offset, container sizing. Okay, let me take a look at you. Flat. Text behavior. characters, words. Oh. Hmm. Ba ba ba. It has to be layout, right? Tooltip, focus, mouse, no, input, accessibility, theme. Hmm. Ah. Hmm. Interesting.